Hello and welcome to BINPIPE. Today we'll be going through AWS Technical Essentials. I'm Prasanjit and let's go through the complete Project Omega hands-on exercises from Linux Academy.
Hello and welcome to Project Omega. So, right now you're probably saying to yourself, well, what is Project Omega? So let's dive right into that. Project Omega is a classified development project that is going to be built and run using Amazon Web Services. At this time, we only know the infrastructure requirements of Project Omega. No specific information on what it is or what it does has been disclosed. Everything is on a need-to-know basis, and right now, there are just some things that we don't need to know. But we have a job to do. As the AWS architects, we have been tasked with creating the basic infrastructure of Project Omega so that the development team can start working on the guts of the project. So what is going to be required for Project Omega? Well, we've been given very little information about Project Omega. However, we have been told in general terms what is needed. 1. An AWS account. 2. User accounts for the development team with access to core AWS services. 3. Proper traffic routing into and out of AWS Virtual Private Cloud. 4. A location for bulk storage of files. 5. Servers to host and run Project Omega. 6. A database to store and catalog data. 7. A way to send notifications, email, or text messages to Project Omega's team members based on events that may occur with Project Omega's infrastructure. 8. A way to internally monitor parts of Project Omega's infrastructure. 9. Automate the process of distributing incoming external user traffic evenly across Project Omega's AWS resources. 10. Automate the process of scaling up or scaling down AWS resources based on traffic demand. 11. Set up and configure a web domain that points to Project Omega's infrastructure. And 12. Test the possibility of using serverless technology for Project Omega. So, given all that, there's still one big central problem. We don't know enough about AWS to accomplish these tasks. However, lucky for us, the people behind Project Omega have left us with a guide. This guide is a new interactive format that will provide a more involved learning experience. Following the guide will teach us the essentials needed to use AWS and set up the basic infrastructure for Project Omega. All right, so let's get started. So now that you've had an introduction to Project Omega, I want to take a few minutes and walk you through how to use this interactive guide and discuss how it's going to be used for the duration of this course. Now, the first thing to understand about Project Omega and this interactive diagram is that this is a resource that you have and can use just as I'm using now and will use throughout this course. The link seen here will be provided to you in the course description, as well as several other locations within the course, so you can always find the link and access it whenever you want to use it to follow along with the lessons. So, what is this interactive guide and how is it going to be used? Instead of using traditional PowerPoint slides to convey information, we here at Linux Academy have developed this as an interactive guide with various levels that you can explore and use to learn more about AWS. So first, this is the main page, and this is Project Omega's infrastructure, or what we're going to build. And all the various components have been broken up into different sections, and we're going to use those sections to teach the elements of each one of these services or concepts that we're going to explore. Now, the great thing about this is that almost everything on this diagram is interactive. We can start by turning it all on or off. At any given time, we can turn off various services or turn them back on as we want to explore what different functions are and how services are used or visually placed within AWS architecture. But what we're going to do for the duration of this course is start with a blank slate, and then together through each lesson, we are going to build the infrastructure for Project Omega as we move along. And within each one of these sections, you can click on the related icon on the diagram, and it is going to take you into that section in which you can then view the lessons. So as an example here for S3, you click on the icon on the main diagram, and it's then going to bring up a summary of what this section is going to cover, and then all of the lessons for this particular service. So the first lesson would be basics. And then within S3 basics, you'll see up here, there'll be more pages available. And you can click on those and see definitions, components, diagrams, and information that I want to convey for each lesson. So each video in this course will correspond to one of these lessons within a section. So there's a fluid navigation to this that you'll be able to use and jump into any specific service that you want at any given time. For example, if you want to know more about If you wanted to know more about just the VPC, you can turn that section on, click on the VPC diagram, and then you're going to have all of the VPC lessons here. Now, within each one of these lessons, there's the ability for us to provide live links for you. So at the bottom of each introductory page for a lesson, there's going to be helpful links. And these will be links directly to the lesson that has already been prepared for this particular topic. Also, there will be a link to the AWS documentation specific to the items that we were talking about in that particular lesson. So network access control list was right here for the lesson, network access control lists. And then to navigate through each lesson, you just follow along and can click on the pages. Also, in each section, so if you click on S3, there is going to be a quick reference button up top. If you turn this on, it will cover up whatever else you were looking at, but you can then toggle between Project Omega if you want to review what that is, but then also sections on simplified AWS definitions for all the various services and the official AWS definition for all of the services. So if we happen to be in a lesson, say for S3, and I happen to mention EC2 or SNS or one of the other services that you're not familiar with yet, you can always pause the video, come up here to quick reference, go over to the simplified definition or the official definition and read up on those services just so you have a basic understanding of what they are if at any time you have some confusion. And you can always just toggle this on and off. So another note is that depending on your computer, your resolution, and the size of the monitor that you're using, you may have these pages pop up with different sizes. So if you just mouse over the bottom, it will bring up here for you a zoom feature where you can manually choose a zoom. Usually zoom to page is what you want to use, that works best, or you can manually resize each page. But we are really excited to show off this new type of interactive learning format, and we'd be really happy to receive feedback from all of you who take this course in the community. And throughout the duration of this course, what you're going to find is that as I'm teaching the course, what we're going to do is I'm going to have the live interactive guide over here, and I'm going to be using that to teach concepts and information. But then at the same time, on the other half of the screen, I'll be working in the AWS console, mimicking what I'm teaching here. So these two tools go hand in hand with each other. I'm really excited to give everyone the opportunity to try this new interactive format that we have been working on. And again, this is really the first time that we've tried something like this. So I would really call this a beta test for this type of interactive guide and this type of learning experience. So again, I would love some feedback from any of you on your thoughts for this new type of platform. And again, to find the link for this interactive diagram, please look in the course description as well as the download section of the course. But for now, we will conclude this introduction to Project Omega and this interactive guide. Thank you for watching. You may now move on. Hello, and welcome to Section 1 of AWS Essentials. Now, as you can see right now, we have a complete blank slate. We don't have an account. We have no access to AWS services. So this first section is going to concentrate on getting you set up with account basics. So let's go ahead and turn this section on, and we'll see here that we start with you, the account creator. So let's dive into this section. And this section is going to cover the account basics, in which the topics will include what is AWS free tier, using AWS free tier, how to create an AWS account, and also how to navigate the AWS console. So let's jump right in and start with lesson 1, free tier. And in this lesson, we're going to talk specifically about what is AWS free tier and how to use AWS free tier. For reference, I'm going to click on the free tier documentation link down here. I'll drag it over to my other browser window. And with that, let's jump into the lesson. So what is free tier? AWS free tier refers to the limited free use of AWS resources. The AWS offers free tier as means for users to learn, experiment, and get hands-on experience with AWS service. So it's a great way for people who are unfamiliar or who have never used AWS before to have a means to learn and get hands-on experience without it costing them any money. Almost all AWS services offer some kind of free tier usage. Now, not every single service offers free tier usage, but almost all of the core services and everything that we're going to work with in this particular course will mostly be covered by free tier use. Free tier is available for 12 months after you create an AWS account. So after 12 months, free tier for many services will no longer be available, and regardless of your usage for those services, you will have to pay something. Free tier is only available to new AWS accounts, so if you want to take advantage of free tier use, you will have to sign up for an additional account or an extra account if you have been using AWS to this point and your account is already over a year old. And most notably, you can actually do a lot while only using free tier services. So the free tier featured services, and we can view those services over here, really include the core services of EC2, EBS, S3, RDS DynamoDB, Elastic Load Balancing, SNS, and Lambda. So for your reference, if you click on the link here to bring up this page on AWS free tier service, you can scroll through here, and for each service, you can view the amount of hours or usage you will get in free tier for each particular AWS service. And this is very important to view and understand so that if you are only using AWS for free tier and you want to make sure that you do not get charged, it is very important that you understand how much of each service you can use while under free tier. So I highly suggest that you click on this link and come in and review some of the core features and understand the free tier offering. For example, here, Amazon EC2, you get 750 hours of using various Linux instances or 750 hours using Windows instances. So again, it's just very important to understand that if you do not want to get charged by AWS, you will need to be aware of these free tier limitations. And with that, we will conclude this first lesson. Thank you for watching. You may now move on. Hello, and welcome to Account Basics Lesson 2. In this lesson, we're going to create an AWS account, and this will be a step-by-step walkthrough of how to create an AWS account. And then at the end of the lesson, we will check in on our Project Omega requirements to make sure that we are fulfilling everything that needs to be done for Project Omega. So let's get started. To create an AWS account, the first thing you need to do is follow this link here to aws.amazon.com, which is currently where we are. We want to click on Sign into the console. And here's where we're going to either sign in or create a new AWS account. So the first thing we need to do is input an email address that we want to use for the account. So that's a new email address that I just created for this entire course. I want to make sure to select I am a new user and then select sign in. This will take us to the login credentials form. So we want to go through and fill out this form. Then we need to create a password that we're going to use for our AWS account. We'll click on Create Account. For the contact information part of creating an account, we do at this point want to select on Personal Account. We're not creating a company account at this time, and then we'll fill in the information. Okay, so I did just jump ahead here and filled out all of my personal information. Obviously, I've blacked out the information so that everybody on the internet can't see my personal details. But just like I did, fill in the form, and then we're going to click on Create Account and Continue. Now, as noted over here, you will need a valid credit card in order to create an account. Now, it doesn't necessarily mean that you're going to be charged anything. If you remember from the previous lesson, I talked about AWS's free tier use offering. So as long as you stick and follow the free tier use guidelines, you will not be charged anything by AWS. And also during this course, we will show you how to put in a couple of alerts or fail-safes to make sure that you don't go over a certain spending amount. So at this point, I'm going to pause the video. I'm going to put in my credit card information and click Continue and move on to the next process in this step. Next, we have to go through an identity verification process. Now here, you need to put in the security check code and along with your phone number, and you're going to get a phone call from AWS. So I'm getting a call right now from AWS, and it is going to ask me to input this PIN number.
Hello, this is an automated call from Amazon Web Services. Using the touchpad on your phone, please enter the 4-digit PIN number that was displayed on your screen. You may also say your Amazon Web Services to complete your registration. Thank you for your interest in Amazon Web Services.
Great, now that I have received the phone call from AWS and input the PIN number, I'm now verified and can move on to selecting my support plan. For this, just keep it as basic as that is part of the free tier option. But what the support plan is various levels of support that you can receive for AWS. And this is generally used for somebody that in their personal life is extensively using AWS, or more likely for corporate or enterprise customers. Okay, we are now finished. The account has been created, and all we have left to do now is sign into the AWS console using the credentials that we just created. So there's our email address, and I'll just input the password and sign in. And there we go. We are now logged into AWS. This is our account, and we are ready to start using AWS now. So lastly, for Project Omega, the first requirement that we had was to have an AWS account, and we did that. We created an AWS account. So we have fulfilled the Project Omega infrastructure requirements for this section, which is great. So we can now finish this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, Account Basics Lesson 3, we're going to talk about navigating the AWS console. We're going to take a general tour of the AWS console, including how to find basic services and features. For this tour, we're going to take a look at finding AWS services, how to find documentation, access support, toggle region selection, and find your account settings. Now, before I jump into finding these, one of the things that I want to note is that the AWS console is something that Amazon Web Services has been A/B testing with different versions over the last couple of weeks and months. Now, I've gone back and I'm now re-recording this video because they have now updated the console yet again with what looks like to be their final decision and will be the stable console moving forward. However, as you view the rest of this course, you're going to notice that between some videos and even inside some specific videos, you're going to see the console version change. Now, don't worry about that, because if you're following along, and even if you're watching a video with an older version of the console, you will notice that you'll still be able to find all the relevant services and features and everything that I'm going to talk about here. They just might be in a slightly different place. But if you just look around, you should be able to find what you're looking for, as there isn't going to be any huge fundamental differences between the different versions of the console. Okay. That being said, in this new version of the console, let's take a look first at how to find various AWS services, and we can do that in several different ways. First, on the top under this navigation bar here under services, you can always click on this and it is going to display all of the various services grouped by their category. So under compute, you'll have EC2, and Lambda. Under storage, S3 and Glacier. Under databases, RDS, DynamoDB. Under networking and content, VPC and Route 53. So if you ever want to find or navigate to any specific service, you can always just click on the services button to open them up. You can also use here the AWS services search bar. So you can type in EC2 and you can bring that up, click on it, and navigate to that service. You can also open up here recently visited services to view the most recently visited services that you just used. Also, you can open up all services here, which is going to bring up the exact same list as here under services, but here it's just on the main console as opposed to in a drop-down menu. Then to navigate to any one of these services, say EC2, all you need to do is click on it and you will now be in the EC2 console. To navigate back out, you can always just click on this cube here to navigate back to the console. Or if you're in a particular service, a really quick and handy way to navigate is just to click on this drop-down menu here, and then you can click on another service that you may want to access. And again, you can always return to the main console by just clicking on the cube in the upper left-hand corner. For support and documentation, right up over here under support, you can click on this drop down here and you can go to Support Center. This is where you can ask questions, get answers for various technical issues that you may be having with AWS. You can access forums to ask questions. And also here you can click on documentation to open up all of the services that AWS offers, and then click on that to access the various documentation that Amazon Web Services provide for any particular service. For region selection, and that's something that we're going to talk about in a future lesson, but to quickly toggle between different regions, all you need to do is navigate up here next to support where it says North Virginia, and it may say something different for you, but this is where you can toggle between using different regions. And it's really just as simple as that. However, generally by default, you will probably come up with the North Virginia region. Now for account settings, this is where you're going to view your account information, billing information, and so forth. You just click on your name here, and under the drop down, you can go to My Account, My Billing Dashboard, My Security Credentials, or this is where you can also sign out. So I just click on My Account. Here you can view and edit your account settings, you can view and edit your contact information, and you can also view your bills for each month, for previous months, budgets, reports, anything that you may set up, including your preferences, credits, tax settings, whatever you need to find or use in terms of account settings or preferences can be found just by clicking on your name here and going to My Account. So that is a quick tour of the AWS console and how to navigate and find various services, documentation, support, region selection, and account settings. So with that, I will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. So I've decided to create an additional video here. We can call it a bonus video for the account basics section, focusing specifically on AWS documentation. So here's the thing about AWS documentation, or any technical documentation for that matter, is that it is absolutely necessary for you to be able to know where to locate information and how to use the documentation, because no matter how many certifications you have, no matter how many years you've been using a certain product or service, no matter how much of an expert you may be considered, you are always going to need to refer to documentation at some point. I use AWS documentation all the time. It is a great tool. It is a fantastic resource to answer questions that you may have and discover new and different ways of doing things inside AWS. So I want to spend a few minutes here just to really show you how to access documentation in a more in-depth way and show you the different types of information that you can get. So first, throughout Project Omega, anytime that you drop into a section and go to a specific lesson, there's always going to be a link at the bottom to AWS documentation specific to that lesson. So for example, for Internet Gateway, I have the AWS link here for the Internet Gateway documentation. It brings you right to the documentation for Internet Gateway. So the same thing for availability zones, subnets, or for any one of the lessons. Specifically, the link is right here to bring you directly to that part of the AWS documentation. So working outside of Project Omega, I'm just going to squeeze this over to the side here. When you're in the AWS console, as I reviewed in the previous video, to access documentation, all you need to do is go to support here and click on documentation. This will give you a full list of all the AWS services, which you can then click on and dive into the documentation. But once you do that, things can get a little confusing, and this is where I wanted to dive a little bit deeper. So for S3 documentation, you're going to see there's actually several different types of documentation that you can go to. There's the Getting Started Guide, Developer Guide, API Reference, New Console User Guide, a preview, and just a console user guide. So there's a bunch of different places you can go here to get information and documentation about S3. So unless you're a developer or need specific API calls, generally what you're going to do is you're going to want to go to the Getting Started Guide. This is going to have the basic information about the different features and usage of the AWS service that you are currently in. Now, it comes in several different formats: HTML to view online, and then PDF and Kindle to download and view offline. For the most part, I always just click right here on the Getting Started Guide to the HTML link, and then on the left-hand side here, you get a full navigation. So right here we have Getting Started, Amazon S3 Basics, sign up for Amazon S3, how to create a bucket, how to add an object to a bucket, to view an object, to move an object. So if you see here, there's just kind of a whole bunch of information that you may need in order to kind of get started using AWS. Then there's a where do I go from here? You can look into common use scenarios for backing up and storage, application hosting, media hosting, software delivery, advanced Amazon S3 features, development resources. So there's just a wealth of information here that you may need to access at some point in order to understand a feature or a part of a service better as you start to learn, explore, and use AWS. So just as another example, we can dive into Amazon EC2 here. We can go to the user guide specific here for Linux instances versus Windows instances, or using EC2 section from the command line interface, which was outside the scope of this course. But for Linux, we can click on HTML. And here it'll talk about, what is an EC2 instance, setting up, get it started, best practices, right? How to set up best practices for security, storage, resource management. Then there's going to be a slew of tutorials that you can look through and walk through and read about. Dive into more information about Amazon machine images, creating, an instance store back Linux AMI. Specific instance types, purchasing options, instance lifecycle. So as you can see here, this is just where all of the information is that you may need to either continue learning about a specific service or help troubleshoot, solve problems that you may be having in AWS. Now, another great way to access any one of these resources is just to do a quick Google search for it. So I can just do EC2 AWS documentation, and then it's going to bring up, usually the first result will be something that I'm looking for. So that'll drop me right to this page as opposed to navigating through the console. And as another resource, you can also use Google just to ask the question specific that you may have about an AWS service. And there's a good chance that a link will come up that will actually deliver you directly down to one of these sub areas that talk specifically about the issue or the solution that you may be looking for. So again, I just wanted to create this video to give you a more in-depth look at documentation, because as you learn and start to use AWS, being able to use documentation, to be able to utilize it as a resource to either answer questions that you have or troubleshoot is extremely valuable. Everybody that works in AWS out in the real world in their jobs will constantly use and refer to documentation. So that's not something that you should be ashamed of or think that it's something that you shouldn't have to use, that you should know something. AWS is so big, there's so many services and features and so many little nitty-gritty options that nobody knows everything. And you're going to have to know how to access documentation, find things quickly in documentation if you're going to be a successful, skilled AWS user, architect, or admin. And with that, I will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. Now that we have completed section 1, in which we created an AWS account, it is now time to move on to section 2. So let's activate this section of Project Omega. Here we see our Omega team, and this is our developer team, which consists of Matt, Kunal, and Donna. And through the rest of this course, we will touch on several things looking through the lens of the developer team or setting up AWS services and features to allow the Omega team to work and build the project. For this particular section, we're going to dive into IAM, or Identity and Access Management. The topics that will be covered in this section include what is IAM, IAM setup and configuration, an explanation of and how to use users, groups, policies, and roles. So let's jump in now to lesson 1, what is IAM? And we're going to talk specifically about what IAM is, common use of IAM, and a discussion of the root user. So what is IAM? Before I jump into that, let's just take a look over at the AWS console on where to find IAM so we know where to access it. So right here under security and identity, that should be a clue as to what specifically this service is going to be. And this here is the main console for identity and access management. So IAM is where you manage your AWS users and their access to AWS accounts and services. So the common use of IAM is to manage users, groups, IAM access policies, and roles. And we are going to dive deeper into those common uses in following lessons. Now, something that I want to make special note of here is that the user created when you created the AWS account is called the root user. So just to be very clear about that, when you signed up for AWS, when you put in your credit card information and your address and your phone number, and you put in an email address and you created a password, those are the login credentials for the root user. Now, by default, the root user has full administrative rights and access to every part of the AWS account. By default, any new users you create in the AWS account are created with no access to any AWS services except for the ability to log in. For all of those other users besides the root user, permissions must be given that grant access to other AWS resources. So just as an example, I'm currently logged in as the root user. This was the email and password that I used when I created the AWS account. But if I were to go back to the main page of the AWS console, I can select and access any one of these AWS services. And I can do this by default, because again, by default, the root user has administrative access to every single service and the ability to launch, provision, delete, modify anything in the account. It is the master account. Any other accounts that we create for any users that we want in our account, like the accounts we're going to create for our Omega development team, will start out with 0 permissions, meaning that they will not be able to access or modify anything in the AWS account unless we specifically grant permission. And we are going to discuss in detail how to do that in the following lessons. So for now, that's all you need to know about what is IAM. So you can now complete this video. Thank you for watching. You may now move on. Hello and welcome back. And in this lesson, we are going to focus on IAM initial setup and configuration. The topics we're going to touch on here are IAM best practices, multi-factor authentication, how to create an admin IAM user and group, and how to create an IAM password policy. So the first thing I want to do here in the AWS console is once again go into IAM. And what we're going to do here is we're going to talk about the initial configuration for identity and access management. So a word you're going to hear a lot while using AWS is AWS best practices. And these are guidelines that recommend settings, configurations, and architecture for the purpose of having a high level of security, accessibility, and efficiency. Now, when we create a new AWS root account, it is best practice to complete the tasks listed in IAM under security status. So if you see here under security status, we have 5 tasks. The first of which is already checked off for us, and that is because when we create just a base user account like we did a few videos ago, there were no root access keys that were generated, so that is already checked off as deleted because there were never any to begin with. However, in order to satisfy AWS best practices, we do now want to go through and complete the other items on this list. First, we will activate multi-factor authentication on our root account. So for multi-factor authentication, let's first discuss what multi-factor authentication is. And as stated here, MFA is an abbreviation for multi-factor authentication, and it is an additional layer of security on your root account that is provided by a third party. And it takes the form of a continually changing random 6-digit code that you will need to input in addition to your password when logging into your root account. So how do you get the MFA code? Well, there's two ways. One is through a virtual MFA device, meaning either a smartphone or tablet, for which a commonly used app for both iOS and Android is Google Authenticator. Another option is a hardware key fob, which is a small physical device with a display that can be attached to your keychain. And if that is the option that you like, then you can order that directly from Amazon Web Services. For this particular example here, we're going to create a virtual multi-factor authentication device using a smartphone. So to quickly kind of touch on how multi-factor authentication works from a conceptual standpoint, when you go to log into your root account, you generally provide a username and password, and then you would click accept and you would log in. This puts another step in between where we still have to put in our username and password. However, after that, we're going to be prompted for the MFA code. We then have to go to either the key fob and get the MFA code, or if we have it set up on a smartphone or tablet, we can open up that application, which may be Google Authenticator, and get the MFA code, input that in, then we're able to log into the account. So it creates an extra layer of security where if somebody were to discover or hack or get into our information and get the username and password, they still would not be able to access the account unless they also had the multi-factor authentication code. So to set up MFA, we can click this down arrow here and follow the instructions that are provided to us by AWS. So we'll click here on Manage MFA. We're going to select on a virtual MFA device, but if you wanted to order the hardware device, you could click on that here and follow the next steps. So for a virtual MFA device, we'll click on that. It says to activate the virtual MFA device, you must first install an AWS MFA compatible application on the user's smartphone, PC, or other device. I use Google Authenticator. I already have that set up on my phone, so I'm going to proceed from here with those steps already completed. Next, what it's going to ask us to do is open up the Google Authenticator on your phone or on your device and to snap, using the camera, the QR code that has been presented. So I'm going to do that now. Okay, that was just scanned and saved. I know you can't see that I'm doing it, but believe me that I did just scan the QR code. I now need to put in 2 successive authentication codes that are presented to me on my phone. So there's the first one. And these codes rotate every 10 seconds or so. So I need to wait a few seconds for the next one to be presented. Okay, I have my 2 codes, so I'm now going to click to activate it. So good, so the MFA device was successfully associated. Click Finish. And then if I refresh here, we should now see that we have activated the MFA on the root account. So perfect, so now whenever I go to log in to my root account, I will need to put in the username and password and then open up Google Authenticator on my phone and pull out the MFA code and put that in as part of the login process. Next, we want to take a look at creating individual IAM users. So what we want to realize here is that AWS best practice is to never use your root account for day-to-day use. So the account that we're logged in with right now isn't what we should, even as the account owner, be using on a day-to-day basis. So what we need to do is create another user for ourselves and give that user administrative rights. So for this, we can just follow along and go to Manage Users. We're going to create a new user. I'll call that user Tom, that's me. And I'm going to uncheck Generate an access key for each user right now because I don't need that right now, and I'm going to touch on what that is later, but I'm just going to skip those steps for the moment. Now that I have my user, I want to click on my user and I'm going to add the administrator access policy to this user. Now, I am going to cover this in more detail in the next few lessons, but for now, I'm just kind of going through this somewhat quickly so that I can check off these best practices and move on to talking specifically about users, roles, policies, and groups in successive lessons. So here I'm going to attach that policy to the user Tom, and the user Tom now has full administrative access. I then want to go to security credentials, and for here I want to click on manage password because I need to create a password for myself for this account so I can log in. So I'm going to assign a custom password, so now I can just create any password that I want for the user Tom, which is what I will use going forward. Okay, now if I go back to dashboard here, we do see that that is now checked. So we have created an individual IAM user and we gave that user administrative access. So as the account owner, we can log into a non-root user account and still have full access to modify, change, or use any aspect of the AWS account. Great, so now that that is done, we want to move on to user groups to assign permissions. So with user groups, it can often be more convenient and efficient to set up groups and assign permissions like we just did for the user Tom to the group rather than manage each user individually. So to do that, again, we'll click on this particular item and click on Manage Groups. I'm going to create a new group. I'll call this group Admin. Click Next. And now I need to assign a policy to that group, which I will assign the administrator access policy and create the group. So now I have a group which currently has no users in it, but that group has assigned to it the administrator access policy. And again, I'm going to go through this all in detail in the following videos. Going back to the IAM dashboard, we now see that that is checked off. Last, what we want to take a look at now is how to apply an IAM password policy and talk specifically about what an IAM password policy is. So a password policy dictates the format and expiration rules that must be followed when a user creates or modifies their password. These rules include password length, case requirements, number requirements, non-alphanumeric requirements, password expiration, password reuse, user rights to change their own password, and administrative reset requirements. So basically, what we're doing here is, I'm sure there's been many times in your life when you've gone to a website and they say, ask you to create a password. You type in a password and they're like, it's too short. It needs to be 8 characters, or you need a number or a symbol in the password. That's what we're doing here. We're creating the rules that need to be followed when our users create passwords for themselves. So we could do something like require at least one uppercase letter to be in the password, require at least one lowercase, require at least one number, require at least one non-alphanumeric character. And what these do is obviously this strengthens the security of the password that our users are going to be creating. You can also put in features like enable password expiration. So this is something you could use if you wanted to have even higher security, where you could say after, say, every 30 days or after every 90 days, all passwords would expire and users would have to create new passwords. You could also prevent password reuse for, let's say, 5 times, which means that the user can't use the same password until they've used 5 different passwords. And then there's also the option for password expiration requires administrator reset. So you can choose whatever rules you like for your specific password policy. There are no specific requirements except that you do have to set this up with some sort of rules. And that all depends on the level of security that you want, which will dictate the password strength. So I'm going to leave these as follows, and I will click on Apply Password Policy. And if you like, you can always delete the password policy, come back in here and change it in the future. So back to the dashboard, we now see that that is checked off. And for us here, we have now completed all of the tasks and we are done with the IAM initial configuration. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, IAM Lesson 3, we are going to focus on IAM users and policies, specifically on how to create, use, and manage IAM users, and also understanding IAM policies and how they apply to users. So to get started, we'll do a quick recap from a previous lesson, which was what is IAM, where we talked about exactly what IAM is and the common use of IAM, which is to manage users, groups, IAM policies, and roles. Here, we're specifically going to concentrate on users and IAM policies and how they work together. So let's look at this as a scenario. We have our AWS account, we have IAM, and out here we have an S3 bucket. For now, all you need to know about S3 bucket is that S3 is a storage service provided by AWS, and that is currently a service that our Project Omega development team is going to have to access. However, if we take a look at our account and its current standing, we don't have Matt as a user. So here, if I click under users, the only user we have is Tom. This was the user that I created for myself in the last video, but now we have to create a user for Matt so that he can log in and start to use AWS. So to do that, we need to create a new user, and we'll create one for Matt. And for the purposes of these videos, I'm going to uncheck generate access key for each user because this really goes beyond the scope of this particular course and is somewhat more of an advanced feature, which has to do with accessing AWS resources from the command line interface, which we are not going to cover in this course. So I'll click create. We now have our user Matt. Great. So now we have our user Matt in IAM. So we are now mimicking what is over here in our Project Omega infrastructure. Now, let's say that Matt wants to access an S3 bucket. Currently, if Matt logged in and tried to do that, he would not be able to access S3 because he is currently blocked. He has no permissions assigned to him that grant him access to the S3 service. So what do we need to do to fix that? Well, if we assign a S3 full access policy to Matt, then he will have full access to S3. So let's walk through the process of doing that. To assign a policy to a specific user, we can click on the user's name, click on the permissions tab, and click attach policy. We then want to search for the policy that we're looking for. In this case, we can type in S3. And we can find here Amazon S3 full access. We'll click on that, attach the policy, and now Matt has the policy attached to him, and if he were to log in, he could access S3 and use that as a service. Now, let's create the accounts for Kunal and Donna and round out the user accounts for our Project Omega development team. So again, back to users, create new users. We'll create Kunal and we'll create Donna. Now, the problem is that if they right now were to try to access S3, they would be blocked because they don't have the S3 full access policy attached to them. They will not be able to access S3, whereas right now Matt can access S3. So to fix that, we can simply go into each one of their respective user accounts and attach the S3 policy. And there we go. So now this is a reflection of our account in that we have Kunal, Matt, and Donna, each with the AIM S3 full access policy attached. And if any one of them were to log in and use their AWS account, they would be able to access and use S3 as a service. So that is a quick overview of how users and policies work together in order to access AWS services and resources. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back to lesson 4 of IAM. Here we're going to talk about IAM groups and policies, specifically concentrating on how to create, use, and manage IAM groups and understanding IAM policies and how they apply to groups. So as in the previous lesson, we talked about users and policies. Now we're going to talk about groups and policies. And again, under the common use of IAM is to manage users, groups, policies, and roles. And this here talking about the grouping of groups and policies. So where we left off in the last lesson, Kunal, Matt, and Donna each had access individually to use S3. So I want to make a clean slate here, and I want to show you first how to remove policies, where you can go into users, click on the user themselves, and then click on detach policy. So if I do this for Kunal, Matt, and Donna, we now have a clean slate where none of them currently have access to S3. So what I want to do now is create a group called Dev. So for that, I'm going to click on Groups, create a new group, and we're going to call this Dev. At this point, I'm not going to attach a policy to the group, but I am going to finish and create the group. So we currently have a group with 0 users. What we want to now do is move Kunal, Matt, and Donna into the group Dev. So for that, we will click on the group Dev, and then under users here, we're going to click on add users to group, and we're going to click on Donna, Kunal, and Matt. Now Kunal, Matt, and Donna are all in the group Dev, but if any of them were now to try to access S3, they would be denied, since neither the group nor any of them individually have the S3 access policy attached to them. Now, one of the nice convenient things about groups is that to give Kunal, Matt, and Donna access to S3, instead of having to assign individually the policies to Kunal, Matt, and Donna, we only need to attach the policy to the group itself. So here under permissions, I can attach a policy. We'll do the S3 policy again. And I just attached the policy to the group, not to the individual users. But since the individual users are part of the group, all three of them now have access to S3. So this is a great way to simplify the process of granting or restricting access. So as an example, what would happen if I were to go back to users of the group and remove Matt from the group? Well, what would happen is Matt would lose access to S3. Kunal and Donna still have access to S3 through the policy attached to the group that they belong to. But now, since Matt is currently no longer in the group, as you can see here, it's only Kunal and Donna, he now no longer has access to S3. So to restore access, all I would need to do is add him back to the group. And just like that, Matt once again has access to S3, and all of our developers have access to S3. So that is a quick overview of groups and policies and how and why they are used. And with that, we will complete this lesson. Thank you for watching. You may now move on. Hello and welcome back. In IAM Lesson 5, we're going to talk about IAM roles, and specifically how to create, use, and manage IAM roles, understand IAM roles and how they are used, and finally, we're going to check in on our Project Omega requirements to make sure that we are fulfilling everything that we need to for Project Omega. So again, to quickly recap about IAM and how it's used, we've already discussed users and policies, groups and policies, and now we're going to talk about roles. So let's take a look again at our current IAM setup where we have Kunal, Matt, and Donna as our three users. They are currently all members of a group called Dev, and they have access to S3 through an IAM S3 full access policy that is attached to the group. Now, roles are a bit different in that, let's say, for example, that we have an EC2 instance, which it's okay if you don't know what that is right now, but basically this is a virtual server, and we're going to dive deep into EC2 in a future section. But this is a service as opposed to a user. So let's say that there is software running on an EC2 server, and that software needs to access information that is in an S3 bucket. So we have one AWS service trying to communicate and talk with another AWS service. Now you may just think, well, let's just assign the S3 policy and that will grant access to the S3 bucket. But with AWS services, you can't directly assign policies to other AWS services. First, you need to attach a role, and then to the role, you can attach policies. What the role does, in essence, is give permissions to another AWS service to almost act as a user. So we can assign a role to an EC2 instance that has the S3 full access policy attached to it, thus granting the EC2 instance access to S3. Now to do that, we come over to the navigation and click on roles, and we're going to create a new role. We can call this EC2. Click on next. And here, there's going to be many different options for AWS service roles. And we see here the very first one is Amazon EC2, and this allows EC2 instances to call AWS services on your behalf. So since we want to use this role for EC2 instances, we will have to select the EC2 service role. If, for example, we're using AWS Lambda and we wanted to give AWS Lambda access to S3, we would create a role and choose the AWS Lambda service role to create that role. But for this, we're going to click Amazon EC2. And now here, we're going to type in S3, and we're going to assign the Amazon S3 full access policy to the EC2 role, thus giving EC2 instance, once we would attach the role to the instance, it would give it permissions to access S3. So you can almost think of roles as a group, but for other AWS services as opposed to AWS users. And finally, let's take a look at Project Omega and see if we have completed all the tasks that are required for this section. So user accounts for the development team with access to core AWS services, 3 IAM user accounts, 1 for each member of the dev team. Yep, we've done that. An IAM group for the dev team. We have done that. IAM policies attached to the group granting access to S3, EC2, and RDS. Now, we haven't done all of that yet. We've only attached a policy granting access to S3 to the group. So now let's go through and attach the other policies. We'll click on the dev group, and again, it only currently has the S3 full access policy assigned to it. So we want to attach an EC2 policy and an RDS policy. So again, we can just go to attach policy. We'll type in EC2 and we'll type in F for full. There we go, EC2 full access. And then we will do the same for RDS full access. Great, we have now fulfilled all the requirements for Project Omega in this section. And with that, we will conclude section 2 of AWS Essentials, in which we covered identity and access management. So moving back to our main diagram, we have now finished the account basics section, the IAM section, and next we are going to move into VPC. And with that, we will conclude this video and conclude this section. Thank you for watching. You may now move on. Hello, and welcome to the start of section 3 of AWS Essentials. In this particular section, we're going to dig deep into some of the real meat of AWS, and I think that this is really where a lot of the fun starts to begin. So, this is what we're going to be talking about in this section, the AWS VPC. Now, there's a lot that I just threw on here, but what this really is the backbone of the infrastructure of any systems that we decide to build in AWS. And over the course of the next few lessons, we're going to dive in and talk about all of these different components. So without further ado, let's dive in. So AWS Essentials, Section 3, Virtual Private Cloud, or better known as VPC for short. So the topics we're going to cover in this section include an overview of AWS Global Infrastructure, VPC Introduction and Explanation, how data travels through AWS architecture covering Internet gateways, route tables, network access control lists, and subnets. So let's jump into lesson 1, AWS Global Infrastructure, in which we're going to talk briefly about regions, availability zones, and data centers. Now, if you took the AWS Concepts course that we offer here at Linux Academy, this will be a bit of a rehash, and I'll be moving through this fairly quickly. But AWS Global Infrastructure starts with AWS regions, and regions are grouping of AWS resources located in a specific geographical location. So looking at the map down here, which is provided by Amazon, each one of these dots here, circles, is either a current region or a pending region which they are developing. And these regions are designed to service AWS customers or your users that are located closest to a region. So regions are really just pockets or areas where AWS resources are located. So if you're located in the United States on the East Coast, you want to use AWS services that are actually run on servers in that geographical area. Therefore, there is less latency in terms of data transfer between you and the AWS servers. Another side of that is you may be located in the United States, but you have customers which you are serving in Tokyo. Say you have a web application where people in Tokyo are accessing it. You don't want them to have to connect to a web server in North Virginia. You want them to be able to access a server in Tokyo, which you have set up and run through your AWS account so that the users in Tokyo can access the web app there with as little latency as possible. Now, each region is comprised of multiple availability zones. Now, availability zones are geographically isolated zones within a region that house AWS resources. And availability zones are where specific physical AWS data centers are located. And multiple availability zones in each region provide redundancy for AWS resources in that region. So what I mean by that is in North Virginia, there will be multiple availability zones, and these are actually specific data centers that are separated regionally. So what this allows is that, let's say for instance that you're storing data in a Amazon S3 bucket. The S3 service is going to back up your files across multiple availability zones. So say that there's an earthquake or a fire or a power outage at availability zone 1, you will still be able to access your files because they will have been backed up at availability zone 2 and availability zone 3. So multiple availability zones provide redundancy for the AWS resources, and this is part of AWS's highly available fault-tolerant architecture. And then drilling down into each availability zone is where you find an actual physical data center, which is where all the actual hardware is that runs Amazon Web Services. So all of the wires, the circuits, the computers, the storage, the servers, all of the components that make the cloud run are located here. And I always kind of find it really funny and interesting when we refer to Amazon Web Services and similar services as cloud computing, when really everything is occurring in traditional data centers. So now when you look at the actual data center, you then really come back to this, which is the diagram that we have been working with so far in its entirety. And all I want you to take from this is that in these actual data centers, that is where all of this is actually taking place. So your VPC, your EC2 instances, your databases, SNS, S3, IAM, all the things that you do when you're using the console here, right? You're really just logging in and using systems that are located in a physical data center, which are located in an availability zone, which are located in a region somewhere around the world. Right now, I'm currently in the North Virginia region. So that means that if I use any services here, what I'm actually doing is launching and using services right here in North Virginia in one of these availability zones in the physical data center. So with that, it's a quick overview of AWS Global Infrastructure, and that starts the process of us learning about AWS VPC. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, we are going to dive into VPC basics, specifically VPC definitions, conceptual VPC discussion, VPC components and data flow, and accessing a VPC in the AWS console. So I'm actually going to start with that last part first. So over here in the AWS console, to access your VPC and use modifier change any of the various things we're going to talk about in the next few lessons, just scroll down under networking and click on VPC. And this here is going to be the section we're going to be concentrating on for the next few lessons. So to get started, what is a VPC? Well, VPC is short for Virtual Private Cloud. And here I've provided a simplified definition and an AWS definition. For the simplified definition, this is really more how I want you to conceptually think or understand VPCs for the purposes of just kind of learning what they are and for the purposes of this lesson. And then we'll talk about the AWS definition, which becomes a little bit more advanced. But for the simplified definition, a VPC is a private subsection of AWS that you control, in which you can place AWS resources such as an EC2 instance and databases. You have full control over who has access to the AWS resources that you place inside of your VPC. Now, with the AWS definition, Amazon Virtual Private Cloud, or Amazon VPC, lets you provision a logically isolated section of the Amazon Web Services cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. Now, a special note here, when you create an AWS account, which we've already done, a default VPC is created for you. So if you look here in your account, you will see there's already one VPC. This is your default VPC, and it comes pre-made with subnets, access control lists, internet gateways, route tables, everything that you need to make the VPC work. But we're going to discuss all of these components. Now, if you took our AWS concepts course, you will recall that I created an analogy between Facebook and a VPC, which I'm going to quickly review again here. The way I want you to think about VPC is very similar to the way that you may think about Facebook in terms of how they are designed conceptually. So with Facebook, you have your homepage, your friend has a homepage, and I may have a homepage. And in your own homepage, you can post things, right? Videos, photos, or posts, and you can decide who has access to view your post and who doesn't. It's very much the same way when you think about your VPC, in that in Amazon, everybody has their own VPC. You have one, I have one, our friends will have one. And in our VPC, we will put things like EC2 instances or RDS databases, and we'll have protection around that in which we can only allow in certain people that we want to allow in or block out others. So this is a very simplified way to look at what a VPC is, but I think it's a very good analogy for somebody who's just trying to understand the basic concept of what a VPC is. Now, taking this a step further, let's look at a different way to conceptually explain what a VPC is. And for this, I want you to think of your home network. Whether you have ever thought about it or not, if you have internet access in your home, you have your own private network. And what are the common components of a home network? Well, you have wires, right, that come into your house from the street, which connects you to your internet service provider. You have a modem, which is your connection or gateway to the internet. You have, again, wires connecting your modem to the router. You have a router or switch, which is the device that allows you to connect devices to the network and routes traffic to other devices on the network or through the modem out to the internet. The same is applied to traffic coming into the network. And lastly, you have computers, cell phones, or any other smart devices that you own. So I want you to just conceptually understand your home network in that you have your devices, the computer or the phone you may be watching this video on right now, and those are connected to a router, which may have a wireless access point or it may be hardwired. Your router is connected to a modem, and your modem is what connects you to your internet provider, which allows you to connect to the internet. So you have this flow of data anytime that you send or request information from something external to your home private network. But your home private network is private, meaning that nobody can get onto your home network unless they have your passwords to access your router and connect to your network. So now let's look at a couple of examples of scenarios with what might happen if certain parts of your home network were to become disabled. So if you were to remove or disconnect the cable, DSL, or fiber modem that you have that connects you to the internet, well, then internally, you can actually still communicate with devices using the router. The router itself does not need an internet connection to allow one computer in your network to talk to another. So you can share files between your computer and your phone using your router without ever having an active internet connection. However, if we switch that around and your wireless or wired router was disconnected or disabled, you would actually still have an internet connection coming into your home or your private network because the modem would still be connected to your internet provider, but your computer or phone would have no way of actually connecting to the modem. So you need every one of these components in order to have a fully functioning working network that has internet connection. So now let's reorganize this information into something that looks more like our VPC diagram on our main page. So here we have the internet. Information flows through and connects to our cable DSL fiber modem, which is the entry point into our home for our private network. That is then connected to our router or switch, which then provides the route to the various devices that we may have connected. And for a lot of us, without even realizing it, we do have a firewall in place, which is a level of security within our private network. So with this image in mind and this understanding of our home network, now let's take a look at what the components of a VPC are. Well, if we kind of switch back and forth really quickly here, we're going to see some very similar things. So first, the internet up here is the same. Then we have our cable DSL or fiber modem. And now we have, for our VPC, an internet gateway. Next, we have a route table, and that replaces our router or switch. Then, instead of a firewall, there is a network access control list. And instead of a laptop or cell phone, we have EC2 instances. So I make this comparison because I want you to be able to easily conceptualize what's going on here with a VPC. So just as with our home network, we have the internet connection coming into our home through our cable modem, then that connecting to a router or switch, which will route traffic to specific devices depending on which device we are currently using. And there's a level of security. It's the exact same thing in the VPC, and I just want you to really have a good picture of this in your head of the way that data flows. So let's pretend that this is our computer that we're using. If I want to access a website, I'll type in the URL. It's going to send the information out through the route table, through the internet gateway out to the internet. It's going to get that website, and then information is going to come back in through the internet gateway, through the route table, and the route table is going to tell us which computer to go to, and it's going to pass through the security layer and then back to that computer. So there's a real similarity in terms of just basic simplified architecture between your home network and a VPC. So again, to sum this all up, it is your private section of AWS where you can launch and provision AWS resources and control all aspects of it just like you do your home network. So let's make a couple of notes here. So again, when you create an AWS account, by default, a VPC is created for you, including the standard components that are needed to make it functional, including the internet gateway, a route table with predefined routes to the default subnets, a network access control list with predefined rules for access, and subnets to provision AWS resources in, such as EC2 instances. So everything here has already been made for you by default, except for these actual instances. These have not been created yet. But the entire infrastructure, all of these components, all of the way that the data flows from the internet into your VPC and back out again is already there for you to use. So with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, we are going to build upon VPC basics and this time talk specifically about internet gateways. And we're going to specifically identify the internet gateway definitions, function of the internet gateway, attaching and detaching an internet gateway, creating an internet gateway, and some basic internet gateway rules. So, internet gateways, also known as IGW, we'll see that abbreviation a lot. For a simple definition, it is a combination of hardware and software that provides your private network with a route to the outside world, meaning the internet, for the VPC. In terms of an AWS definition, an internet gateway is horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. It therefore imposes no availability risk or bandwidth constraints on your network traffic. So just to kind of sum up those two definitions really quick, for the simple definition, just think of the internet gateway as your cable modem, right? Or as the modem that you use to connect to the internet. It is the entryway either into or out of your private network. And with the AWS definition, I really want you to focus on redundant and highly available, and allows communication between instances in your VPC and out to the internet. So with that being said, let's again take a look at our VPC diagram and understand internet gateways, and take a look back over at the VPC dashboard in the console on where you find internet gateways. So over here under Virtual Private Cloud in the navigation, you can either click on any of these here or any of these here to kind of dive deeper into the VPC components. But for now, right here, we're going to click on Internet Gateways and take a look. So here is our Internet Gateway. This is the default gateway that was created when we created our account and had the default VPC created for us. It has an ID. The state is attached, and it does state the VPC that it is attached to. So if you look here, the VPC that is attached to ends in CB5C. So now if I switch over to VPCs, you'll see that the VPC that we currently have in this account ends in CB5C. So these are just using the VPC identifiers, ID numbers, as well as the Internet Gateway identifiers, just to kind of understand and link the two together so that we know which component is assigned to which VPC and vice versa. So clicking on the Internet Gateway itself, you can see some more information that's down here. And there's not a whole lot of information here. Again, it just tells us that it's available, it is attached, and it is attached to this particular VPC. And what I mean when I say attached is this. It means that it is currently attached to the VPC and routes are provided. Now, I can easily come up here and detach it from the VPC. So when I click detach from the VPC, what's basically happened is this. It's just gone from the VPC. It's still in my account, but I've now removed it from the VPC. And what has now happened is that anything inside the VPC, these instances or any other AWS resources that I would have had provisioned, now would have no route out to the internet. So they would still be able to communicate with each other, and I'll get into that in the next lesson, but they would have no way of accessing the outside world. So I can do one of two things. I can either create a new internet gateway and attach that, or I can simply just reattach this particular gateway. And if I just want to reattach it, I can just, again, it's selected here, attach to VPC, select whatever VPC. I currently only have one VPC in my account, click attach, and just like that, it's back and our VPC has a route out to the internet. To create an additional internet gateway, I just click here on create an internet gateway. I'm going to give it a name. I'll call this Essentials Internet Gateway. I'll create it. And there it is. It's created. It has a name, and that is available to be attached to any other VPC that I decide to create in the future. Now, a couple of things that we do want to know about internet gateways, besides the fact that they provide our connection to the internet for our VPC, is that only one internet gateway can be attached to a VPC at a time. So you can't have 2 or 3 internet gateways on a VPC. You can only have one. So I can't attach this here. So if I go to attach, right, it's not going to give me an option to attach it because I don't have a VPC, which currently does not have an internet gateway attached. And an internet gateway cannot be detached from a VPC while there are active AWS resources in the VPC, such as an EC2 instance or an RDS database. So if we currently had any live resources provisioned in this VPC and I wanted to detach it, it would give me an error saying that it would not allow me to do that. So that is a quick review of what an internet gateway is. And with that, we will conclude this video. Thank you for watching. You may now move on. Hello, and in this lesson, we're going to continue building on VPC basics, this time talking specifically about route tables and touching on route table definitions, the function of a route table, creating and deleting a route table, and setting routes in the route table. So to start off, let's talk specifically about some route table definitions. So the simplified definition is, well, the AWS definition is simple enough, so let's just jump right down to it. A route table contains a set of rules called routes that are used to determine where network traffic is directed. And we should note here that your default VPC already has a main route table. So let's take a look at that right here under route table, or you can always click on it here. This is our main route table, and we know that it's our main route table. Under the column here, it says yes for main. Now, before we dive into the various aspects here on the console, let's take a look again conceptually at what the route table does. So in our VPC diagram, we have our internet, we have the internet gateway, which we discussed last lesson, and that's what provides us with access to the outside world for VPC. But then once inside our VPC, we need something to tell the data where to go. So when information comes in from the internet, say a website, a computer in the VPC would have requested that information. So the information that's coming back in has a little packet of information with it that says, hey, this is the computer or this is the server that this information needs to go to. And it's the route table that takes that and says, okay, this is the one that you need to go to, or maybe there's one over here that you need to go to. But it's the route table that provides the connection between all of the various resources within your VPC. And back here under the console, if we look down here next to summary and we click on routes, this is what tells us what's attached to this route table and where things are going to go. So the first thing I want you to look at and concentrate on here is this part right here, which is IGW, which, if you haven't already guessed, stands for the Internet Gateway. So this right here, this connection represents this line right here. This is the connection or the route between the route table and the Internet Gateway. The other section here, this is the IP address or the CIDR block range of the VPC itself. So this here is basically these lines here that provide the route around the internal aspects or the internal parts of the VPC. Now, for demonstration purposes, let's have a little bit of fun. Let's click on our Internet Gateway here to open up Internet Gateways in a new tab. And if I clear out the auto sort here, we can see our two internet gateways, the one we have attached, BB8, and the one that I created in the previous lesson. So the BB8, that's the one that we have connected. That's the one currently right here in our diagram. What would now happen if I were to detach this from the VPC? Well, let's give it a try and see what happens. So I detached it from the VPC, and basically what's happened now is this. I've detached the internet gateway from the VPC, but the route table is still routing to it. So let's click back and let's refresh the route table page. Click on the route table and click on routes. And now here under this, before where it said active, it now says black hole. So that just means that the route to the internet gateway is just going nowhere. It's going to a black hole. So any information sent through it would just go off into the nether regions. So if we were just to simply reattach this particular gateway, well, we would just go right back to this and everything would work just fine. But for this example, let's now attach the other gateway that I created to the VPC. So now I have another internet gateway here, but we're still routing to the gateway that has been detached. We're still routing to the BB8 detached internet gateway. So if I now edit this and remove that route and add another route, the drop-down is now going to give me the option of adding the Essentials Internet Gateway. I can click Save. All destinations must be a valid CIDR block. So this, I'm just going to put 0 and click Save. We now have an active route to the internet through an active gateway. And that brings us right here now to this diagram where this was our default internet gateway that was detached. So we detached it. We attached a new internet gateway to the VPC and we switched the route. So we took the route that was going to this internet gateway, and when we changed that here, we changed the route now to the internet gateway that's attached to the VPC, and we have now restored internet access to the VPC. So I just want to make sure that you have a good understanding of what route tables do and how they work within a VPC. Now, there are a lot of advanced features to a route table, but for the purposes of the AWS Essentials course, I just want you to conceptually understand its purpose and how it routes and connects different elements and components of the VPC with each other. So again, to sum up, a route table contains a set of rules called routes that are used to determine where network traffic is directed. And unlike an internet gateway, you can have multiple active route tables in a VPC, and you cannot delete a route table if it has dependencies associated with it. So just to kind of show you what I mean by that, let's create a new route table. I'll call this Essentials Route Table. And again, we only have one VPC to select from, so I'll click Create. And we now have a route table, which is not our main route table and does not have any subnets explicitly associated with that. We'll talk more about that when we get to the subnet sections. But for our default route table, which does have subnets, internet gateways, and things routed to it, if I were to try to delete this right now, it would not work. Comes up and it says you cannot delete the following route table. It has dependencies. It cannot be deleted. But if I were to click on this, delete this route table, because it has nothing associated with it, now it can be deleted. So again, just wanted you to be aware of those two aspects, that one, you can have multiple route tables in a VPC, which we're going to use in a little bit. And then also you cannot delete a route table if it has dependencies. So with that, I thank you for watching. We will conclude this video. You may now move on. Hello, and in this lesson, we're going to continue building on VPC basics, this time focusing on subnets. Now, I know this has been a long time coming. I'm sure you may have looked at subnets in previous lessons and on the main diagram and wondering what the heck is going on with those and why have we waited this long to get to them. Well, in this lesson, we are going to talk specifically about the definitions of a subnet, the function of subnets, understanding public versus private subnets, and how to make subnets public or private. First, let's start off with a few definitions. So the simplified definition would be a subnet, shorthand for subnetwork, is a subsection of a network. A lot of subs in that sentence. Generally, a subnet includes all of the computers in a specific location. So circling back to the home network analogy we used in the VPC basics lesson, I want you to think about your internet service provider as being a network, and then your home network being considered a subnet of your internet service provider's network. So your internet service provider you can think of as a large network spanning your city or your town, and your home being a subnet in that it's its own little network within a larger network. Now, technically, that's not a great analogy, but just conceptually, that's how I want you to think about that. And it's going to make more sense in a minute when I move on to the next few slides. But in terms of an actual definition from AWS, when you create a VPC, it, meaning the VPC, spans all of the availability zones in a region. After creating a VPC, you can add one or more subnets in each availability zone. Each subnet must reside entirely within one availability zone and cannot span zones. So again, I want to note that your default VPC already has subnets created in it. So we can view those here by clicking on subnets or subnets here. In the North Virginia region, the VPC will come pre-populated with 4 subnets because there are 4 availability zones within the North Virginia region. So if we look at these subnets here, we can see the availability zones that they are in. So I'll sort this by name. And currently, for each one of these subnets, we have a subnet in US East 1B, US East 1C, US East 1D, and US East 1C. So they're each within a separate availability zone. And this is so that we can provision resources in these various subnets so that they are in different availability zones, which creates fault tolerance, availability, and redundancy. So again, looking at our VPC diagram, here is a public subnet, another public subnet, a private subnet, and then another private subnet. So you may now be asking yourself, well, what's the difference between a public and a private subnet? Well, the main difference between the two is that public subnets have a route to the internet, where private subnets do not have a route to the intranet. Here I've pulled out a public subnet and here a private subnet. So if you look here, I just took this part here and this part here and just kind of moved it up here, replacing this subnet in the diagram. And for a public subnet, it is going to have a route. It is going to be connected to a route table, and the route table is going to have an internet gateway attached, and that is going to allow information and data to flow in and out of the subnet to and from the internet. A private subnet also has to have a route table associated with it, or have the other way around, a subnet associated with a route table, but the route table cannot have an internet gateway attached. So this allows information to flow from one subnet to another within the VPC, but it will not allow traffic to go to and from this subnet through the internet gateway and out to the intranet. So how does that actually work practically, meaning in the AWS console? A second route table without an internet gateway. So let's do that first. So I opened up the route table section of the VPC. I'm going to create a new route table. And what I want to do now is associate a subnet with this particular route table. But first, I want to make sure that I've labeled things correctly so I know what is public and what is private, or what I want to be public and what I want to be private. So let's go back to our subnets. And right now they have no names. And when you create a subnet, you have to give the subnet a name, but you can also go in at any time for your default ones and give them a name. So let's call this, and we'll match the naming construct that we've been using on the diagram. We'll call this public subnet 1. Click save. We will call this public subnet 2. Private subnet 3. And private subnet 4. So basically what I've done here is if I go back to the previous diagram, I've just now labeled my 4 subnets to match what's going on here. But just because I labeled them public and private, again, does not make them public or private. What makes them public or private is if they have a route to the internet or do not have a route to the internet. So currently, all 4 of these subnets have a route to the internet, because if I look at the route table for every single one of them, all of them are going to have a route table with an internet gateway attached. So they are all currently public subnets. So in order to make public subnets private, I need to change the route table associated with the subnets that I want private to a route table which does not have an internet gateway attached. So the one that I just created does not have an internet gateway attached, but I now need to associate the subnets that I want with this particular route table. So under the route tables, I will click on subnet associations. I will click edit, and then I'm going to select the 2 that I labeled private. So I now have 2 explicitly associated with this route table, and I know here it says 0 explicitly associated with this route table. Let me relabel this the default route table for simplicity. But if I look at the default route table, and again, it comes back to this main option here, I don't have any subnets explicitly assigned or associated to the default route table, but because it is the main, if there are subnets that aren't explicitly associated with another route table, then by default, they'll be associated with this. But I can go in here just for simplicity and to make this nice and clean and associate these 2 directly or explicitly with the default route table. And once that's done loading, what we're going to have is something that looks internally like this. So we have public subnet 1 and public subnet 2. I'll refresh this here. So for public subnet 1 and public subnet 2, those are associated with this route table here, which is this route table right here. So both are associated with this route table, which has a route to the internet. So those are public subnets. For these other two, the private subnets 3 and 4, they are associated with the route table that does not have an internet gateway attached, which is this route table. So in terms of actual flow of data, if we were to say have an RDS instance in the private subnet, data would flow in and out of the private subnets using the route table without an internet gateway attached and still be able to communicate with instances in the public subnets, but would not have, again, access or a route to this route table to go out to the internet. But it will need to communicate with the other route table in order to route traffic to the public subnet. So I know that gets a little bit confusing, but I hope this diagram makes sense, and just be very confident in the fact that subnets associated with a route table that does not have an internet gateway attached will be private subnets, meaning that traffic to and from the internet cannot occur, and subnets that are associated with a route table with an internet gateway will have traffic to and from the internet. And regardless, internally, they'll all still be able to communicate with each other, regardless of whether or not they are public or private, as long as they are within the same VPC. So, okay, I know that was a lot, but let's just sum everything up and talk specifically about some of the rules that we need to know. So subnets must be associated with a route table. A public subnet has a route to the internet. I know we're repeating this a lot, but this is something you really have to know and be comfortable with understanding. A private subnet does not have a route to the internet, and a subnet is located in one specific availability zone. So if we look back at our diagram here, we have availability zones. A subnet has to be only in one availability zone, as where a VPC can span multiple availability zones. And we'll get to more on that in a second. So with that, I will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. We are closing in on the finish of the VPC section of this AWS Essentials course. But now we're going to circle back around to availability zones, which I did touch upon in the infrastructure lesson, but this time I'm going to talk about how they're used specifically within the VPC and what they mean for VPC subnets and other aspects of the VPC. I'm going to touch on how availability zones work within a VPC, high availability and fault tolerance. And then at the very end, we're going to talk about Project Omega requirements and make sure that we have done everything that we need to do for the Omega project. So let's jump right in, and we're going to take a closer look at the definition of availability zones. Now, I know I already talked about this, but we're going to go through this one more time because going over these things again and again will be very helpful and important. So any AWS resource that you launch like EC2 or RDS must be placed in a VPC subnet. Any given subnet must be located in an availability zone. You can and should utilize multiple availability zones to create redundancy in your architecture. This is what allows for high availability and fault-tolerant systems. These are two terms you are going to hear endlessly when you're working with Amazon Web Services. For a bit of a more defined definition, we can look to AWS, and they say that when you create a VPC, it spans all of the availability zone in that region. After creating a VPC, you can add one or more subnets in each availability zone. Each subnet must reside entirely within one availability zone and cannot span zones. Availability zones are distinct locations that are engineered to be isolated from failure in other availability zones. So if you remember back to the infrastructure lesson, when I had the availability zones laid out and they were geographically separated from each other. By launching instances in separate availability zones, you can protect your application from failures in a single region. So this is very important, and this is one of the core benefits of using cloud services in AWS in general. What I mean by this exactly is if we look at our VPC diagram, we have 2 availability zones in this diagram, although we actually have 4 availability zones for this VPC to use. What we want to try to do when we build applications and systems in AWS is to have resources or duplicate resources span availability zones. We have resources in one availability zone and we want duplicates in the other. So let's say, for example, we have a website which we are hosting in AWS. And for that, we have a primary web server. Backing that up, we have a primary RDS database that is providing content and information to the web page. So if a customer accesses our website, their information comes in through the internet gateway, through the route table to this particular web server. That web server may then, through the other route table, through the non-internet connected route table, will access this subnet, grab information, populate the website, and send the information back to the customer. Now, in another availability zone, we want to have a backup web server and a failover RDS database. This is important to have set up in case this availability zone goes down. So if there's an earthquake, a fire, a power outage, or for some reason the data center in this availability zone fails or these become inactive, well, then we can just simply switch over to our backup instance and our backup database, and therefore our downtime will be either low or non-existent, and our customers won't have any service interruption while trying to use and access our website. So traditionally, if you have a data center or if you're hosting a web server in your home or in an office and that were to go down, you may not have a backup in a different geographic location. But here, these 2 availability zones may be separated by 100 miles, 50 miles, 200 miles, 500 miles, and something disastrous can happen in one availability zone and you can have backups in another availability zone that can quickly be provisioned and launched, or can already be provisioned and launched and just waiting for something to happen here, and then you can fail over to the services that you have in a different availability zone. So that's the importance of availability zones in building highly available and fault-tolerant architecture. So again, one of the few things we just want to focus on is high availability. Creating your architecture in such a way that your system is always available or has the least amount of downtime as possible. What high ability sounds like is this, and this is something that somebody would say. I can always access my data in the cloud. It is always available. It is highly available. My website never crashes and is always available to my customers. So when somebody is properly using high availability architecture, this is something that they would say. For fault tolerant, again, that is the ability of your system to withstand failures in one or more of its components and still remain available. So what fault tolerant sounds like is somebody saying, one of my web servers failed, but my backup server immediately took over. Or if something in my system fails, it can repair itself. And we're going to get to that in later sections. But it is very important to understand the concepts of high availability and fault tolerance within cloud architecture so that as you move forward and start to use AWS, you can use best practices to make sure that your systems are highly available and fault tolerant. So again, summing up availability zones, they are distinct locations that are engineered to be isolated from failures and other availability zones. And that is the main takeaway that you need to know about availability zones. Okay, so since we've now come to the end of this section, let's take a look at Project Omega infrastructure requirements and see if we have met everything that we need to do. So for section 3, we needed proper traffic routing into and out of our AWS virtual private cloud. Okay, so first, one internet gateway attached to the VPC. Well, let's take a look at internet gateways. We do have one internet gateway, and it is attached to our VPC. One route table with a route to the internet. Let's take a look at our route tables. One route table, it should be this one right here, with a route to the internet. One route table without a route to the internet. If I click on my other route table, there is no internet gateway attached, so there is no route to the internet. So great, that satisfies that condition. Two public subnets, each in a separate availability zone, and two private subnets, each in a separate availability zone. Again, we meet this condition if we look at our subnets. We have two public and two private subnets, and we know that because the two public subnets have a route table that has an internet gateway attached, and our two private subnets have a route are associated with a route table that does not have an internet gateway attached. And if we scroll over and we look at availability zones, we see here that each one of them is in a separate availability zone. And again, that is to create highly available and fault-tolerant architecture. So, great. We have now finished this section in which we talk extensively about virtual private clouds. Now, there's also so much that I'm not able to get into in a shorter course which concentrates just on the essentials. But hopefully this gives you a very good overview of what a VPC is, what it's used for, how it works, and what its various components are in terms of the way that data flows in and out of VPCs and in and out of Amazon Web Services as a whole. So with that, let's go back to our main diagram, and we see here we have now conquered the VPC section of Project Omega, and next we're going to start to dive into specific AWS services starting with S3. So with that, we will complete this lesson and complete this section. Thank you for watching. You may now move on. Hello and welcome back. To this point, we've really been focusing on a lot of the real fundamentals of AWS in terms of getting our account set up, setting up users, understanding policies and permissions, as well as exploring the backbone of the AWS infrastructure in the way of the virtual private cloud. In this section, we're going to move into more specific AWS services, which really become the daily drivers for most people and organizations. Specifically, we're going to now talk about Amazon S3. So let's dive into that now. So for AWS Essentials Section 4, the topic is Simple Storage Service, or S3, and in this section we're going to cover topics that include introduction to S3, a pricing and cost overview, managing buckets, folders, and objects, uploading and downloading objects, storage classes, use cases, and cost, object life cycles, permissions, and object versioning. For this lesson, lesson 1, we're going to start with S3 basics, and we're going to talk specifically about S3 definitions, components and structure, and a pricing and cost overview. So S3, or Simple Storage Service, is an online bulk storage service that you can access from almost any device. For the AWS definition, Amazon S3 has a simple web service interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. it gives any user access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. The service aims to maximize benefits of scale and to pass those benefits on to users. So basically, this is Amazon's storage service where you can upload and store any type of files with almost unlimited storage capacity. And before we dive into more of the basics, let's just take a quick look over here at the console and see where to access S3. So down here under storage and content delivery, right here, the very first service listed is S3. And if you've never used S3 before, the first thing it's going to prompt you to do is to create a bucket. But before we do that, let's at least understand what a bucket is and what the various components are of S3. So as we just discussed in terms of the very basics, S3 being simple storage service, and it is AWS's primary storage service, and you can store any type of file in S3. It has several components being buckets, folders, and objects. And first, for buckets, root level folders, and I'll explain that in a second, you create in S3 are referred to as buckets. Any subfolder you create in a bucket is referred to simply as a folder. So I use the term folder here just to make a comparison to a folder that you may have on your computer. If you look at your desktop right now, you may have a folder which you use to store files in, and then in that folder you may have a subfolder. Well, with S3, the root level folder, meaning the lowest level folder, is what is referred to as a bucket. Then within the bucket, you can place objects or create subfolders for then which you can put objects in as well. So I'll show you a diagram of what I mean about that in a minute. But now let's move on to objects. So files stored in buckets are referred to as objects. So you have your main folder, then you can have subfolders inside the bucket, and then objects can be your files, whether that is a Word document, an Excel document, it could be a presentation, it could be music files, pictures, movies. Any file is just referred to as an object. Next, we should just understand quickly how regions work with S3 buckets. And when you create a bucket, you must select a specific region for it to exist in. That means that any data you upload to the S3 bucket will be physically located in a data center in that region. So best practice is to select the region that is physically closest to you to reduce data transfer latency. If I'm located on the East Coast of the United States, I don't want my personal buckets to be located in the Tokyo region, because then the data is going to have to be transferred halfway around the world and back, and that transfer will just take a longer amount of time. However, if you are serving files to customers based in a certain area of the world, create the bucket in a region closest to your customers. So again, and I gave this example a few sections ago, where if I have customers in Tokyo that I want to service, then I want to put the files that they are going to access in the Tokyo region so that their latency is lowest as possible. And as a side note, I do want to make mention that some AWS services only work and communicate with each other if they are in the same region. Now, this is more of an advanced feature, and it's probably something you don't have to worry about as you're just learning AWS, but it's just something to keep in the back of the mind that if you have some services located in one region and some services located in another, they might not be able to communicate with each other directly. Either way, again, something that's really more advanced or outside the scope of this course, but something I just wanted you to be aware of conceptually. So now let's take a look more at the structure and what I mean in terms of root, bucket, subfolders, and objects. So within S3, if you create a bucket, that is your root folder, as I'll call it, in terms of making comparison to something you may have on your home computer. Then within the bucket, and you can have multiple buckets, but within one specific bucket, you can just place an object and have that in a bucket, or you can create a subfolder and also have an object placed inside of that subfolder. So this is just kind of some basic organization. I just wanted you to see the difference between a bucket and a folder in terms of its naming construct and how it may be a little bit different than how you call folders on your home computer. So I just want to be very clear about just the slight change in the naming construct. So now let's briefly discuss the pricing and cost for using S3. So first, let's just take a look at this link down here. I've included a link directly to S3 pricing. So if we open that up in another tab, and I'll drag that over here so we can look at both. Free tier is available for AWS, and currently what is available for AWS S3 free tier is listed right here, which currently includes 5 gigabytes of S3 storage, and then 20,000 get requests, put requests, so on and so forth. But the important thing to understand is that included in the free tier is up to 5 gigabytes worth of storage. Now, in terms of how you are charged primarily based on storage costs, and this applies to the data at rest in S3. You are charged per gigabyte used, and price per gigabyte varies based on the region and storage class. So I'm not going to go into detail for all of the services in terms of understanding the differences between regions, but you can click here and change the different regions, and you will see that prices will change based on region. Now, for every service that we're going to talk about for the rest of this course, pricing will vary per region, and I'm not always going to identify that as so, but just know that moving forward, using different regions will always have a slightly different cost for different services. So beyond just basic storage and the amount of data that you store in S3, there's also request pricing, and that is moving data in and out of S3. And this is certainly something that you may not have to worry about immediately, but you will be charged based on things like put, copy, post, list, get, lifecycle transition request, data retrieval, data archive, and data restore request. And again, all of that information can be viewed here on the pricing page in terms of the cost for each. So it's always really important to understand the pricing structure of how various things work with not only S3 but other services as well before you really start to use any AWS service on a large scale. Because AWS, although can be very inexpensive to use, for certain features and under heavy usage can become quite expensive. So always be sure to understand what the pricing structure is and what you're going to be charged. But if you are just using S3 to upload some personal files or backups for yourself, most likely you will fall under the free tier usage and won't be charged anything. But be very mindful of pricing when using Amazon Web Services. Okay, now that we were done with the pricing and cost overview, that will conclude this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, we're going to talk about buckets and objects, specifically how to create a bucket naming rules, uploading objects, creating a folder, and navigating S3 properties. So first, let's revisit this diagram from the previous lesson, as this is what we're currently going to build in S3 so we can see a live example of how to create a bucket, add a folder, and then upload an object at the bucket level, and then also upload an object into a subfolder. So in order to do that, the first thing that we need to do is create an S3 bucket. So over here in the console, let's go to S3. And since I currently have not used S3 in this account, it is going to immediately prompt me to create a bucket. And the first thing I need to do is give the bucket a name. Now, there are a few things that are very important to understand and know here, and that is that bucket names must follow a set of rules. These are the most basic rules, and that is bucket names must be unique across all AWS. What I mean by that is that for everybody, everywhere in the world using AWS, using S3, bucket names cannot be duplicates. So if I have a bucket called my S3 bucket in my account, you can't have a bucket in your account called my S3 bucket. Everything has to be unique across every account, across every user in the entire world for AWS. So that can create a bit of an issue in that you may not be able to have a bucket name that you want. So a lot of times you will have to get creative with your bucket names. Bucket names must be a minimum of 3 and a maximum of 63 characters in length. Bucket names can only contain lowercase letters, numbers, and hyphens, so you cannot have capital letters in your bucket name. And also, bucket names may not be formatted as an IP address. Okay, so let's create a bucket. I'm going to call this Project Omega Bucket 1, and let's see if that's taken. See, I already made a mistake there. I put a capital just by habit. And next we need to select a region. So I'm going to select US Standard and click Create. Okay, good. So that bucket name was not taken. So I was the first one to request that bucket name out of everybody using S3 in the entire world. So that's good. So next, let's talk about uploading or importing an object to a bucket. To do that, we want to navigate into the bucket. So we do that just by clicking on it here. Now we are inside of the bucket, and we can go right up here to the upload button. I can click on Add Files. I'm going to go to my Documents tab, and I'm going to upload Project Omega File 1. Click OK, start upload. And there we go. That uploaded. It is now in my bucket. So it's really that simple just to upload to S3. So clicking back to the root, here is my Project Omega bucket, and inside here is my Project Omega File 1. Now to create a folder, all I need to do is click on Create a Folder, and I can call this Folder 1. Now, folder names can be capitalized and have very different rules than bucket names do. So I can then navigate into the folder, and then I can upload an object directly into the folder by doing the same process as before. And let's upload Project Omega File 2. Okay, so just going back here, I now basically have this structure set up. So I have my bucket here, which is Project Omega bucket. Then in the bucket, I have an object, which is Project Omega File 1. I have a subfolder, which is Folder 1. And then inside the folder, I have another object. So really, to create buckets, folders, and uploading objects is really that simple. So next, let's take a look at buckets, folders, and object properties, because this is how you are going to use and modify buckets, folders, and objects moving forward. So back to the bucket level. If I select a bucket without clicking on the name, but click on it over here and then click on properties, it's going to bring up this list of various options, and we are going to dive into some of these over the next few lessons. So the top part of properties is always going to be general information about the bucket name, the region, the creation date, the owner, that is who created the bucket. And then going down through the rest of these, there's a lot of different features and functions that we can use here in S3 on the bucket level. And we're going to talk specifically about permissions, versioning, and life cycles over the next few videos. Then navigating into the bucket, if I click on the folder, now if you notice I didn't click on the folder, but just on the line, it highlights it. And then if I click on properties, I can view properties for the folder, which in this case is just general info and details. For an object, I can do the same thing. I can click on an object here, and I can view properties for the object. Now the properties for the object vary a bit, but I have the bucket that it's located in, the name, a link, and we'll get to that in a later lesson, and then the size, the time it was last modified, and some other information about the file. And then detailed permissions metadata, we are going to get into these in the next few lessons. But what I want you to take from here is just how to navigate around S3 in terms of accessing properties on the bucket level, accessing properties on the folder and objects level as well. That's going to be very important to you to understand as you move forward and start to use S3. So with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we're going to talk specifically about S3 storage classes, touching on topics that include storage class definitions, description of each storage class, object durability and availability, and how to change between storage classes. So let's first define what storage classes are. And a storage class represents the classification assigned to each object in S3. Available storage classes include standard, reduced redundancy, or RRS, infrequent access, or S3IA, and glacier. Each storage class has varying attributes that dictate things like storage cost, object availability, object durability, and frequency of access to the object. Each object must be assigned a storage class, and standard is set as the default storage class. You can change the storage class of an object at any time. Well, for the most part, but I'll get into that shortly. So anytime that you upload an object to S3, you should be thinking to yourself, which storage class is right for me? And that's what we're going to talk about in the rest of this lesson. So for the 4 storage classes, let's go through specifically the details of each. First, standard, and this is designed for general all-purpose storage. It is the default storage option of S3, meaning that when you upload an object to S3, unless you deliberately change it during the upload process to a different storage class, it will be uploaded as standard storage class. Now, to view the storage class of any particular object, just click into a bucket, and if you look at an object right here under storage class, you're going to see the storage class classification. So continuing on, standard has an object durability of what is referred to as 11 nines, which is because there is 11 nines in their percentage. Also for object availability, that is set at 99.99%, and standard is the most expensive of the various storage classes. Now, if you don't know what object durability and object availability are, we're going to get to that in the next slide. For reduced redundancy storage, this is designed for non-critical, reproducible objects. And you'll notice it has a much lower object durability, but the same object availability. And it is less expensive than the standard storage class. So you're getting a cheaper storage class, but you're giving up some of your object durability. For infrequent access, this is designed for objects that you do not access frequently, but when you do need to access that object, it must be immediately available. And this has the same durability as standard in that it has 11 nines durability, but the object availability is slightly lower at 99.9% as opposed to 99.99%. And this is, again, even more less expensive than the standard or RRS storage class. Lastly, we have Glacier, and this is designed for long-term archival storage. And this is a very special type of storage class in that if you store files in Glacier, first off, it is extremely cheap, just a few cents per gigabyte of storage, and it has exceptional durability. But if you want to retrieve objects stored in the Glacier storage class, you have to put in a request, and it may take several hours to a day in order to retrieve those files. So it's only good for archival storage for objects that you're almost never going to have to retrieve. And if you do have to retrieve them, you are okay with waiting at least a few hours. So next, let's talk about object durability and object availability. These are very important concepts when talking about S3 objects. So object durability is the percent over a 1-year time period that a file stored in S3 will not be lost. In other words, for object durability of 11 nines, that means that there is a 0.000000001% chance that a file stored in S3 at 11 nines durability will be lost in a year. Or we can look at it this way: if you have 10,000 files stored in S3 at 11 nines durability, then you can expect to lose one file every 10 million years. So object durability has to do with a file being lost or corrupt. The higher the durability, the better the chances are that a file stored in S3 will never be corrupt or never be lost. Next is object availability, and this is the percent over a 1-year time period that a file stored in S3 will be accessible. Now, for object availability of 99.99%, that means that there is a 0.01% chance that you won't be able to access a file stored in S3 within a given year. Or for every 10,000 hours, you can expect a total of 1 hour for which a file may not be available to access. And I know I'm kind of interchanging the word file and object here. I just do that a lot myself. But when I say file, I mean object. When I say object, I mean file. They're terms that you can use synonymously with each other. But what's important to know about these two terms is that object availability has to do with me accessing this file, meaning that when I click on it, is it accessible? Can I download it? Can I modify it? Can I access the file? Durability has to do with the file actually being there. Is it lost? Is it corrupt? Has it been deleted somehow? That's the difference between durability and availability. And obviously, one of the main benefits of using S3 is its extremely high durability and availability. And this goes into AWS's claim of always having highly available and fault-tolerant systems. So highly available and highly fault-tolerant. That's the way you should think about these two terms. So let's take a closer look at actually changing or modifying the storage class of a file. So again, by default, all new objects uploaded to S3 are set to standard storage class by default. So Project Omega File 1 set to standard, and if you look at Project Omega File 2, that is also set to standard. So if we want new objects to have a different storage class, then you need to set the proper settings prior to or during the upload process. And you can do this by either setting another storage class during the upload process, and I'll show you an example of that in a second, or using object lifecycle policies. And we're going to cover that in the next lesson. But let's take a look at uploading another object and how to set a different storage class during the upload process. So if I click on upload and I select a file, and I'll select the same file again, I'm not going to upload it this time, but I'll show you how to do this. Instead of hitting start upload right away, if I select set details, here I can choose a different storage class. So if I now click start upload, it will upload and set the infrequent access storage class as the storage class for that file during the upload process. Next, for the following storage classes, being standard, reduced redundancy, and infrequent access, you can manually switch the object storage class amongst them at any time by changing the storage class in the object's properties. So if I click on this object, click on properties, go to details here, make sure that that's open, I can select standard, infrequent access, or reduce redundancy. By simply clicking save, and I can hit refresh here, and we see that that is now switched to reduced redundancy. This can also be done to a folder. If I click on a folder, click on properties, I can change, let's change this to infrequent access. I can click save, and then any objects within the folder will be changed. Now, it doesn't set that as the default for the folder, meaning if I now were to upload another file into this folder, it would take on whatever properties I set during the upload process. But if there is a folder and I just want to change everything at once for a one-time shot, then I can do that by changing the storage class on the folder level. Now, last, let's talk about Glacier, because that was left out of this section here where we're able to manually change. To move an object to Glacier storage class, you need to use object lifecycles. You cannot manually switch an object storage class to Glacier. And the change to Glacier may take 1 to 2 days to take effect, as where when I manually switched these between these 3 storage classes, the effect was immediate. And we're going to get into object lifecycles in the next lesson, and where we're going to go into that in detail. Now, circling back around to the storage classes, given now that we have a better understanding of object durability and object availability, let's just talk about some reasons why you may choose to use these different storage classes for particular objects that you may have. So standard, having the high level of object durability and high level of availability, should be used for either objects that you are frequently accessing. So they may be work files that you are accessing continuously on a daily basis, or files which are extremely important and need that extra level of durability so that there is more security for them to not be lost or corrupt. For reduced redundancy, this is great for backups or for files that can be reproduced. So if you have a copy of a file, or let's say a thumbnail of a picture, you should use reduced redundancy because it's cheaper. And if for some reason with the lower durability, the file were to become lost or corrupt, you would have the original file somewhere else, probably in standard, that you can make a duplicate of and replace the lost or corrupt file in reduced redundancy. For infrequent access, this is designed for objects that you do not access frequently, but must be immediately available when accessed. So what we mean by this is that it has the same level of durability as standard, meaning that the same guarantee that files will not be lost or corrupt. But this is for files that you may access once a week or once a month, files that you're going to have to access, but not access very frequently, because there is generally a cost associated each time you want to access the file. So because of that, it is less expensive, but it's only less expensive if, again, you only are accessing the file very infrequently. If you're accessing the file every day, then you certainly want the file in the standard storage class. For Glacier, this is great for large bulk archival storage. So think about a hospital that may have millions and millions of medical records that they have to keep for regulatory reasons, but a lot of those objects or files may be 10, 15 years old. There may be pieces of information there that they're never going to have to access ever again. So because of that, they can put it in Glacier and get extremely cheap storage. But if for some reason they have to retrieve somebody's medical information that is 15 years old, it's not something that needs to be pulled or be available immediately, because it may take several hours to retrieve that from the Glacier servers. So the trade-off there is you have to wait in order to access the file, but at the same time, the storage is extremely, extremely cheap. So that's a quick summary of storage classes, how to change between storage classes, and what object durability and availability are and how they affect how you may use the different storage classes. So with that, I will conclude this video. Thank you for watching. You may now move on. Hello, and in this lesson, we're going to talk about S3 object lifecycle, specifically talking about lifecycle definitions and using object lifecycles. So, what is an object lifecycle? Well, an object's lifecycle is a set of rules that automate the migration of an object storage class to a different storage class or deletion based on specific time intervals. For example, I have a work file that I'm going to access every day for the next 30 days. After 30 days, I may only need to access that file once a week for the next 60 days. After which, meaning 90 days total, I will probably never access the file again, but want to keep it just in case. By using a lifecycle policy, I can automate the process of changing the file's storage class to meet my usage needs and keep my S3 storage cost as low as possible. So, can you figure out what the lifecycle policy would look like and which storage classes should be used for each time interval? Take a second to think about that. See if you can figure it out. Well, again, here's our scenario. A work file that I'm going to access once a day for the next 30 days. Then after 30 days, I may only need to access that file once every week for the next 60 days. And then after 90 days, I will probably never have to access that file again, but will want to keep it. So what is the best solution to meet the usage needs and minimize cost? Well, the solution would look something like this. So for days 0 to 29, being the first 30 days, my usage needs are very frequent. So the best fit storage class would be standard, and the cost is the highest cost tier. But for the next section of time, being days 30 through 89, total of 60 days, my usage needs are infrequent, meaning once a week or once every 2 weeks. So the best fit storage class for that would be infrequent access, because even though I may only access it once a week or once every 2 weeks, there will be times when I need to access it, and when I want to access it, I need that to be immediate. So the cost there is middle tier cost, so slightly less expensive than standard. For 90 plus, my usage needs equal most likely never needed. So the best fit storage class would be Glacier, because this then provides the lowest cost tier. So the object lifecycle would look something like this. From day 0, when it's uploaded, to day 30, it will remain in standard storage class. Then on day 30, it will transition automatically to standard infrequent access. Then at day 90, it will automatically transition the object to Glacier, where it will remain from day 90 plus. Now, if I wanted to, I could also set a date, let's say 1,000 days in the future, to delete the file. So there's a lot of different options that you can use when creating an object lifecycle. But the purpose, again, of the lifecycle is to automate the process based on your usage needs to help minimize your storage costs. So in terms of lifecycle management, lifecycle's functionality is located on the bucket level. So let's take a look at that. Click on the bucket, click on properties, and we're going to see here that lifecycle is listed here. So, however, a lifecycle policy can be applied to the entire bucket, applied to all the objects in a bucket, one specific folder within a bucket, and then applied to all the objects in that folder, or applied to just one object within a bucket. And you can always delete a lifecycle policy or manually change the storage class back to whatever you like. So with that understanding, now let's actually create this lifecycle policy. So on the bucket level, under lifecycle and properties, we'll click on add rule. So the first thing I need to decide is, am I going to apply this rule to the entire bucket, meaning that all files currently in the bucket will be applied to this lifecycle policy, and then all new files that are uploaded will also fall under the rules of the lifecycle policy. Or I can choose a prefix, meaning I can select a folder or a folder and then an object in the folder to apply the lifecycle policy to. For now, we're just going to stick to the entire bucket. We'll go to configure rule. So first, we're going to look at actions on objects. So transition to standard infrequent access storage. Well, yes, that's the first thing that we want to do, because by default, the object is going to come in as the standard storage class. So we don't have to set it to standard for the first 30 days, but we are going to say that 30 days after the object's creation date, pre-populated there for me because that's a common selection. So 30 days after the object's creation date, we want to transition the object to standard infrequent access storage. Then we want to transition it to archive to Glacier storage. And we will set that not from 60, but to 90 days out. Then if we look here, we'll see here that this matches exactly what I have down here. So I just built the scenario in which we were talking about, in that from days 0 to 29, or the first 30 days, the object will remain in standard storage class, then transition for 60 days to infrequent access, and then transition to Glacier. And if I wanted to, I could always put in a permanently delete the file, and I could set this to any number that I want. So if I set this to 1,000, then after 1,000 days that the object has been in S3, it will delete that. So it's a great way that if maybe for regulatory reasons you have to keep files, say, for 5 years or 7 years, after which they can be deleted, then you can set that time period here and the files will be deleted, and then you will no longer be charged for storing those objects. So I'm going to click review and click create and activate rule. So now that rule is live and active for our Project Omega bucket. And with that, I will conclude this video. Thank you for watching. You may now move on. Hello, and in this lesson, we're going to continue learning about S3 functionality, this time concentrating on S3 permissions, specifically permissions definitions, setting and using permissions, and making an object publicly available. So let's dive right in and start talking about what are S3 permissions. Well, S3 permissions are what allow you to have granular control over who can view, access, and use specific buckets and objects. Permissions functionality can be found on the bucket and object level. So let's first take a look at the bucket level. So clicking on properties and then opening up the permissions tab. Let me open this up here so we have a little more room. So on the bucket level, we can control who has access to the bucket and its contents using these various policies, or adding or removing permissions. So currently, for any grantee, we can either choose for that person, and this is me in my account right now, to be able to list or to see the bucket, to upload or delete to the bucket, to view permissions, meaning this right here, or edit these permissions. So for example, right now, even though our development team, if you remember Kunal, Donna, and Matt, they have an S3 bucket policy attached to them via the group that they are in, so they can access and use S3. But since I created this bucket and currently the only grantee is me, none of them would be able to use or access this bucket, although they would be able to use and access S3 to create their own buckets. But if I wanted them to be able to access this bucket, I would need to add permission. And for this, I would have to say, okay, everybody can now list, upload, or delete, meaning that they can now come in and they can upload, download, use the objects in this bucket, but they wouldn't be able to view these permissions or edit these permissions. So it's just one way that you can use permissions to grant or deny access to specific buckets. On the object level, if I click on an object, go to properties, and view permissions, we're basically looking at something similar, but it's slightly different. For this, it is just open and download, view permissions, and edit permissions. So I can give somebody access to the bucket, but then I can also restrict access to be able to open or download for specific objects within a bucket. And we can also share specific objects via this link here with the outside world. So say that you uploaded a file to S3, but you wanted to share the file with a friend or a coworker or somebody else that doesn't have access to the AWS account. Well, one of the really cool things is that you can do that. We can make this a publicly downloadable file. And we do that on the object level, creating the following permissions. We're going to create the grantee as all or everyone, and we're going to only select open and download, and we're going to save. Then up under actions, we're going to click on make public. And now watch what happens to this link here. If you see this little lock here, after I select make public, I'll click OK, go back to properties, and we're now going to see that the icon changed and it is now available. So if I right click, copy the link address, or to open up a new tab or provide this to somebody else, they would be able to open, view, and download the file. So a really cool, neat way to upload something to S3 and share it with the rest of the world, especially for those people that don't have access to your AWS account. So that is a quick overview of S3 permissions and how they're used specifically to either grant or restrict access on the bucket or object level. So with that, I will conclude this video. Thank you for watching. You may now move on. Hello, and in this lesson, we're going to continue learning about Amazon S3 by focusing on object versioning, specifically versioning definitions, using versioning rules, and lastly, since this is the last lesson of this section, we're going to check in on our Project Omega requirements and make sure that we have everything done that we need. So jumping into versioning, what is S3 versioning? Well, S3 versioning is a feature that keeps track of and stores all old and new versions of an object so that you can access and use an older version if you like. Now, there's some very important things to understand about versioning. Versioning is either on or off, and this is done at the bucket level. Once it is turned on, you can only suspend versioning. It cannot be fully turned off, and I'll show you an example of that in a second. Suspending versioning only prevents versioning going forward. All previous objects with versions will still maintain their older versions. And versioning, again, can only be set on the bucket level and applies to all objects in the bucket. So here's our bucket. Let's click on Properties. And we'll open this up a little bit again, and we'll click on versioning. By default, when you create a bucket, versioning is off, so you have to enable it. So I'm now going to enable versioning, click OK. And as you see here, I can't turn versioning off again, but I can only suspend versioning. But let's go into our bucket and let's take a look here at Project Omega file 1. Now I've updated the file on my computer, and we're now going to upload an updated version of this file and see what happens. So I've now uploaded the second version of this file. So now one of the things you should recognize is that up top here, there is now this toggle for version hide or show. Currently it is set to hide, but if I click on show, it is now going to open up this Project Omega file 1 and show the two different versions, the one that I uploaded earlier in a lesson and the one that I just uploaded in this lesson. Now, a couple of things that you should note. One, the previous version was set to reduced redundancy storage class, but when I uploaded the second version, I didn't specify which storage class it should be set to, so it's set to standard by default. So very important to understand with versioning is that just because a previous version has a certain storage class does not mean that the new version will adopt that storage class. But if we look at these two files, I can now take action on either one of these two files. I can download either one of these two files. And if I ever have any issues with the newer version, I can always look at the older version as a backup, something I can revert to if I need to. So this is a great way just to kind of have this redundancy, have backups built into S3 by having versioning turned on. Now, obviously, this is going to increase the storage that you use, thus increasing costs. So that's always something to be mindful of. But nonetheless, this is a great feature. So now going back to the bucket level, well, actually interesting here because I have this split screen here and this new toggle is being shown. I guess it kind of squished everything together and I lost my ability to navigate. But if I just move this over here, okay, that comes back. So going back to the bucket level, if I select the bucket and click on properties, for versioning, if I now were to suspend versioning, what's now happened is that the objects that I currently have in S3 will have their previous versions, and those versions will always be stored and made available. However, any new objects that I would upload to this bucket would not have versioning enabled on those new objects. So just as an example, if I go back into the bucket, there is still the ability to view and see versions of the files that were created when versioning was enabled, even though versioning is now disabled. But if I now upload a new object here and then upload a newer version of that object, because versioning is now suspended, versions will not be kept just for that new object. So that's a quick overview of versioning, and hopefully that makes sense to everybody. And now, before finishing this lesson and concluding this section, let's take a look at our Project Omega infrastructure requirements. So for section 4, S3, we needed a location for bulk storage of files. And specifically, we needed one S3 bucket for storing objects. We have that. Project Omega files uploaded to the bucket. We have done that. Versioning turned on for the bucket. Well, we did turn it on, but then I did suspend it. So we'll have to go back and turn that back on before we finish up here. And then lastly, a lifecycle policy enabled to move objects to Glacier after 90 days. And we have accomplished that. So let's quickly jump back over to the bucket level. Go to properties and we will re-enable versioning. Great. So That is now enabled, and we can now complete this section and this lesson. So let's again do a quick recap and overview. This was AWS Essentials Section 4, in which we learned about Simple Storage Service, or more commonly known as S3. Back to the main page, we have now completed Account Basics, IAM, VPC, and S3, and next we are going to move on to EC2. So with that, I will conclude this lesson and conclude this section. Thank you for watching. You may now move on. Hello and welcome back. I'm very excited to start this section because we really get to dive into more of the meat of Amazon Web Services, this time focusing on EC2. So without further ado, let's click on over here to Project Omega and turn this section on and dive right in. So Elastic Compute Cloud, commonly referred to as EC2, is what we're going to be covering in AWS Essentials Section 5. We're going to cover the topics that include an overview of AWS Elastic Compute Cloud, Amazon Machine Images. We're also going to have a review of instance type components. We're going to cover EBS volume basics and snapshots, how to use security groups with EC2, IP addressing, and finally launching and logging into an EC2 instance. So let's get started with our first lesson, EC2 Basics. And in this lesson, we're going to cover specifically EC2 definitions, a conceptual overview of EC2, EC2 components. We're going to talk about what makes up EC2, common purchasing options. That's a very important aspect of this, and also a general pricing overview. So let's start off with a few definitions. So EC2 is an abbreviation for Elastic Compute Cloud. For a simplified definition, think of EC2 as your basic desktop computer. That's really all EC2 is. It's just a computer that you're using that's just somewhere else. It's an Amazon cloud computer that you've decided to use. And it essentially has the same parts internally as the computer that you're using right now to watch this video. In a very simplified form, just think of it simply as that. It's a computer. For a more in-depth definition, let's take a look at the AWS definition. Amazon Elastic Compute Cloud, Amazon EC2, provides scalable computing capacity in the Amazon Web Services cloud. Using Amazon EC2 eliminates your need to invest in hardware upfront so you can develop and deploy applications faster. You can use Amazon EC2 to launch as many or as few virtual servers as you need, configure security and networking, and manage storage. Amazon EC2 enables you to scale up or down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. So what I want you to really take away from this is, again, just think of EC2 as a computer in the cloud at an Amazon data center that you're using. It's as simple as that. Now, there's a lot of different variations of EC2 that you can use, and that's what we're going to cover throughout the rest of this section. But also, just keep in mind that the purpose of EC2 is that it's scalable, meaning that it can easily grow in size if needed. And you can launch as many or as few, again, and EC2s are virtual servers that you need. So it's scalable. You can increase the amount of compute power that you need basically on demand or instantly, and you can launch as many or as few as you like. Simple as that. Great, let's move on. So conceptually understanding EC2, I want you to picture just your basic computer. And what are the components that make that up? Well, you have your operating system. Either, in this case, we'll just refer to either Linux or Windows. You have a CPU for your processing power. You have a hard drive, your local storage. You have a network card, something that allows you to connect to the internet. You have a firewall for security, and there's also RAM. And these should be components that you are already fairly familiar with. Now, flipping this over to an EC2 instance and its components, let's just compare these two diagrams. Instead of an operating system, when setting up an EC2 instance, you have AMIs. Instead of CPU, think of instance type. Instead of a hard drive, think of EBS. Instead of a network card, think IP addressing. Instead of a firewall, think of security groups. And for both your home computer and EC2 instances, there is just straight up RAM. Now, this is an overly simplified comparison between the two, but it's not too far off in terms of the choices that you need to make when deciding what type of EC2 instance to launch. And conceptually, the way I really want you to understand this is that there really isn't a huge difference between an EC2 instance and a computer that you have at home. An EC2 instance is just a virtual computer in the cloud that you use and provision, and it has many of the same components that your desktop computer or laptop computer has, just with some slight variations in its naming construct and how things are categorized and grouped together. And we're going to go through all of these options over the next few lessons. Now, an important thing to understand about EC2 is that there's different purchasing options. So let's jump over to the console here, and I'll show you how to access EC2, and it's actually the first option here right under Compute. And this will be your hub for launching and maintaining all of your EC2 instances. Currently, we have 0 instances running, and by the end of this section, we will have provisioned at least 1 EC2 instance. Now, in terms of launching EC2 instances, there are several options that you can choose from. And these three are the most common. The first, and probably the one you're going to use the most at the beginning, are on-demand instances. So on-demand purchasing allows you to choose any instance type you like and provision or terminate it at any time, meaning on demand. It is the most expensive purchasing option, but for that you get the most flexibility in terms of being able to launch one whenever you like or delete one whenever you like. You are only charged when the instance is running and billed by the hour, and you can provision or terminate it on demand, again, at any time. For reserved instances, reserved purchasing allows you to purchase an instance for a set period of time of 1 or 3 years. This allows for a significant price discount over using on demand. You can select and pay upfront, partial upfront, or no upfront. And once you buy a reserved instance, you own it for the selected time period and are responsible for the entire price, regardless of how often you use it. So it's very important to understand the difference between these two. On demand, if I just need an instance for an hour or 2 hours or a day, I can buy it, I can pay for what I use, and I have that flexibility, but it is the most expensive purchasing option. Reserved allows for a great discount, but I am paying a guaranteed cost, which is going to be either the cost for a year or 3 years. And once I sign up for that reserved instance, I am then locked in to owning that instance for that amount of time and paying that full amount. Now, optionally, there is spot pricing. Now, spot pricing is a way to bid on an instance type and only pay for and use that instance when the spot price is equal to or below your bid price. This allows Amazon to sell the use of unused instances for short amounts of time at a substantial discount. Spot pricing fluctuates based on supply and demand in the spot marketplace. You are charged only by the minute, and when you have an active bid in place, an instance is provisioned for you when the spot price is equal to or less than your bid price. and provisioned instances automatically terminate when the spot price is greater than your bid price. Let's hypothetically say you're paying $2 an hour for an on-demand instance. You can put in a bid price or a spot price for, say, 20 cents an hour for that same instance type. And if the spot market for that instance type goes below 20 cents per hour, then it will automatically launch and provision the instance for you, and you will have that instance to use at the price of 20 cents per hour for as long as the spot price is below your bid price. But the second the price goes above your bid price, then you will lose access to using that EC2 server. So with this option, you can get the lowest price per hour, but you also have the least amount of flexibility, meaning that in a given week, maybe you'll only get access to an EC2 instance at your price for a few hours. Maybe you'll get luckier and you'll have access for a few days. But it's the market price that determines that, not your demand. And in the console, to select these different types of purchasing options, you have instances, which is where you can launch an instance on demand, spot requests, where you can put in a spot price, and reserved instances, where you can go in and purchase a reserved instance. So those are the three main ways that you can purchase EC2 instances. And it's important to understand and know the difference between the three. In the rest of this course, we're going to be working with on-demand instances, and as you start to learn AWS, this will probably be the most common option that you choose. In terms of specific pricing, how are you charged for using EC2? Well, you are charged based upon which purchasing option you select, which we just reviewed. You also charge depending on the instance type, and this is the instance processing capacity. In this case, think CPU, and they fall into several categories, which include general purpose, compute optimized, GPU optimized, memory optimized, and storage optimized. And we're going to go into these in more detail when we get to our instance type lesson. There's also EBS optimized, AMI type, data transfer in and out of the instance, and also pricing can vary based on region. There is free tier use available for EC2 for the on-demand purchasing option and only one specific instance type, and we will see that in practice when we actually go into provisioning an EC2 instance later on in this section. And as always, before doing any major usage of EC2, please follow this link and check out all the various ways that you can be charged, because EC2 can be very inexpensive to use, and using the free tier you can do a lot without being charged anything. But some of the higher end instance types and storage capacities become extremely expensive and can cost a lot of money to run. So you have to be very, very careful with what you launch and provision while using EC2. So with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, we are going to talk about Amazon Machine Images, also known as AMIs, specifically touching on AMI definitions, a conceptual AMI overview, AMI components, and AMI categories. So what is AMI? A simplified definition is a pre-configured package required to launch an EC2 instance. So the pre-configured package required to launch a virtual server in the Amazon cloud, including an operating system, most importantly, software packages, and other required settings. For the AWS definition, an Amazon Machine Image provides the information required to launch an instance, which is a virtual server in the cloud. You specify an AMI when you launch an instance, and you can launch as many instances from an AMI as you need. You can also launch instances from as many different AMIs as you need. So the important thing here to understand is that AMIs are a required component of an EC2 instance, and it is the basic software package that you install on the instance, primarily its operating system. And you can launch as many EC2 instances as you like from the exact same AMI. So to understand AMIs conceptually, let's take a look at its components. And it has three main components, which is a root volume template. And this is what includes your operating system and any application software that may be included, launch permissions, and block device mapping, or EBS hard drive mapping. So if you think about an EC2 instance or a Linux EC2 instance, for the root volume template, that would mean the Amazon Linux operating system, including software packages such as Apache Web Server. And then also for block device mapping, this may be EBS mapping to various volumes. Now, the nice thing, or one of the main benefits of Amazon Machine Images, is that you can configure these components any way that you like and then make your own Amazon Machine Image from that template. And when you create an AMI, you are essentially just creating a template that you can use to launch another EC2 instance that has the exact same components as the original. So if I create a Linux EC2 instance with these AMI settings, I can then create my own machine image of this instance. I can then use that machine image to launch 2, 3, 4, 5, 6 different EC2 instances, all with the exact same settings. So using AMIs is a quick way to create additional instances in Amazon Web Services. So when you launch an EC2 instance, the first thing you do is select an AMI. So to show you that, over here in the EC2 console, if I click on Launch Instance, the first step is going to be to choose an Amazon Machine Image. And you're going to see here under Quick Start, there's going to be a bunch of images listed. And the primary way that these are designated are by operating system. So whether it's Amazon Linux, Red Hat, SUSE Linux, Windows, different versions of Windows. And then within each operating system type, you can then see various other settings and software packages that may come installed on that Amazon Machine Image. Now, for AMIs, there are different types of categories. So the first is community AMIs. These are free to use, and generally with these AMIs, you are just selecting the OS that you want, meaning that's the primary reason why you would use the community AMIs, for a specific operating system and basic installed software packages and settings. And those can be viewed either under Quick Start or by clicking on Community AMIs, for which then you can filter down and select things specific to what your needs may be. Next is the AWS Marketplace AMIs. These are pay-to-use AMIs and generally come packaged with additional licensed software. So taking a look at that, the AWS Marketplace, you will see AMIs that are packaged with various enterprise type software. Last is My AMIs, and these are AMIs that you create yourself. Currently, we don't have anything here because we haven't created anything, but this is something we are going to do later in this course. So to quickly review, again, AMI is the abbreviation for Amazon Machine Image, and what you need to take away from this is that AMIs are what provides the information required to launch the instance, mainly the operating system. At least for the purpose of this introductory course, this essentials course to AWS, that's the way I want you to think of AMIs, is that you are selecting your operating system. As you move into more advanced courses, then you'll start to learn about the various different settings, installation packages, and virtualization types that also come along with AMIs. But for now, that will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to talk about instance types, specifically instance types definitions and instance types components. Starting out with the definitions, let's talk about what is an instance type. For a simplified definition, the instance type is the CPU, the compute power of your instance. For an AWS definition, when you launch an instance, the instance type that you specify determines the hardware of the host computer used for the instance. Each instance type offers different compute, memory, and storage capabilities and are grouped in instance families based on these capabilities. Select an instance type based on the requirements of the application or software that you plan to run on your instance. So when you think about instance type, the main category that I want you to think about is its CPU, its compute power, but it also represents the other hardware components that make up the virtual server that you're going to launch. So now let's talk about the components of the instance types. And to do that, let's also take a look at that in the EC2 console. So to get a good view of all the various options, let's actually go into launch an instance. We're going to select an AMI. We're going to select the Amazon Linux here just as an example to get to this screen here, which is the second step when launching an instance, where we have to select the instance type. So let's go through all of these different options. First is family, and this is a way of categorizing instance types based on what they are optimized to do. So you have general categories. So for family, you have a general purpose instance type. You have a compute optimized instance type. GPU compute, memory optimized, storage optimized. And these are all categories that are designed for a specific purpose depending on, again, the type of application or software you're going to run or use this instance for. Then within each family, you have a type. This is the subcategory for each family type. So this is a naming designation within each family, which then represents the rest of the configuration. For vCPUs, these are the amount of virtual CPUs that your instance type will have. Next, memory, this is the amount of RAM your instance type will have. For instance storage, the local instance storage volume, meaning your hard drive, and here you can see various options such as EBS only or SSD. Next is EBS optimized available. So this indicates if EBS optimization is an option for the type of instance you're going to select. And last is network performance, and this is the network performance rating based on its data transfer rate, basically your bandwidth capacity into and out of the instance. So as you can see, there are a lot of different type of instance types that you can choose from with a lot of different configurations and settings. And as you can probably imagine, there are large price differences between these two. The one you will most commonly use, at least while getting started with AWS, is going to be the T2 Micro instance type, because this is the free tier option. So moving on, we'll just sum this up again. When you think about an instance type, think about the CPU. Think about the underlying hardware that is going to power your EC2 instance, including the type and amount of processors, the amount of memory, the type of optimization for storage, and the bandwidth capacity of the instance itself. So with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to talk specifically about Elastic Block Store, commonly referred to as EBS. We're going to touch on EBS definitions, IOPS, root versus additional volumes, and snapshots. So to get started, let's talk about the definition of EBS. A simplified definition is EBS is a storage volume for EC2 instances. So here I want you to think of it as a hard drive. For AWS's definition, Elastic Block Store provides block-level storage volumes for use with EC2 instances. EBS volumes are highly available and reliable storage volumes that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to an instance are exposed as a storage volume that persists independently from the life of the instance. And we're going to touch on that point again in a few minutes. So before we move any further in talking about Elastic Block Store and how it's used, let's first talk about IOPS, because this is something that, although it's a bit of a more of an advanced feature, it's something that I at least just want you to be aware of. So what are IOPS? So IOPS stands for Input-Output Operations per Second. A simplified definition of IOPS is the amount of data that can be written to or retrieved from an EBS volume per second. AWS defines IOPS as a unit of measure representing input-output operations per second. The operations are measured in kbps, and the underlying drive technology determines the maximum amount of data that a volume type counts as a single I/O. So I/O size is capped at 256 kbps for SSD volumes and 1024 kbps for HDD volumes, because SSD volumes handle small or random I/O much more efficiently than HDD volumes. So what does this all mean? Basically, more IOPS means better volume performance, faster read-write speeds. What determines the amount of IOPS? Well, the largest contributing factor is the EBS volume size. So the larger the storage size in gigabytes, the more IOPS the volume has. Okay, so now that we have some of the technical stuff out of the way, let's talk about root versus additional volumes. So let's be clear about this. Every EC2 instance must have a root volume, which may or may not be EBS. So EBS is not the only type of storage offered by Amazon Web Services for EC2 instances, but it is the most commonly used. So that's why we're only talking about this type here. Now, in the EC2 console, you can go to Elastic Block Store and view your volumes by going right here under Elastic Block Store and clicking on volumes. And here, if you want to, you can create a volume independent of an EC2 instance, or during the instance creation process, if you go in a few screens to storage, this is where you will select the root volume for your EC2 instance. And by default, this is an EBS volume. So by default, EBS root volumes are set to be deleted when the instance is terminated. However, you can choose to have the EBS volume persist after termination. So one of the major benefits of EBS volumes versus older types of storage volumes that AWS used to use is that EBS volumes can persist past the lifespan of the EC2 instance. So if you see right here where it says delete on termination and that is checked, that means that when we terminate this instant, this EBS root volume will be deleted as well. But if I were to uncheck this, then I can terminate the instance and this EBS root volume would still be there in my account, which I could then attach to a different EC2 instance. Now, if I want to, I can also add an additional volume, an EBS volume, to my EC2 instance during the creation process of the EC2 instance, or I can always create an EBS volume anytime afterwards and attach it to the EC2 instance. So this means that we can swap EBS volumes between different EC2 instances by detaching it from one and attaching it to another. So if I were to create this EC2 instance and I have my root volume and then I have my additional EBS volume, just like I have here, I can then at some point in the future create a second EC2 instance, maybe just with a root volume, but I can then take this additional EBS volume, detach it from instance 1, and move it to instance 2. So it's a really nice feature to be able to basically take hard drives and move them or swap them from one instance to another. And when you think about root versus additional volumes, what I want you to think about is if you have a computer at home, you probably have a hard drive that is built into the computer. So if you were to take that computer and throw it in the garbage or the computer were to break, then most likely you would also lose the root volume unless you were to actually open your computer up and take that hard drive out. So think about that the same way here with your root volume. This is the hard drive that is built into your computer, and you have the option to either, when you terminate or when you would throw out the instance, you would have the opportunity to open up the computer and actually pull that hard drive out and save it for later by unchecking this here. But if you keep it checked, that would be similar to you taking your computer right now and throwing it in the garbage and having the hard drive inside go with it. With the additional volumes, this is like having an external hard drive. So if you have a thumb drive, an SD card, or a solid state drive that maybe you plug into your computer but is external, and what you can do with a thumb drive or an external hard drive is just unplug it from your computer and go plug it into another computer at any time. And that's what it's like here, having an extra EBS volume. So next, what I want to jump into is snapshots. So what snapshots are, and those can be viewed right here under the Elastic Store volumes. A snapshot is an image of an EBS volume that can be stored as a backup of the volume or used to create a duplicate. A snapshot is not an active EBS volume. You cannot attach or detach a snapshot to an EC2 instance. However, to restore a snapshot, you need to create a new EBS volume using the snapshot as its template. So if I have an EBS volume and I create a snapshot, that is basically a duplicate or a replica that I can use as a backup to store, and at some point in the future I can launch a new EBS volume and use the snapshot to populate the EBS volume with all the information that was on the original EBS volume. So the benefits of snapshots are to have a great resource for backups, and having a snapshot, because it is not a live active EBS volume, is also a lot cheaper. Okay, so let's sum everything up with EBS. And when you think about EBS, again, just think of it as a hard drive. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to focus on security groups, specifically security group definitions, conceptual overview of security groups, and inbound and outbound rules for security groups. So let's start off with a simplified definition of what a security group is. So security groups are very similar to network access control lists in that they allow and deny traffic. However, security groups are found on the instance level as opposed to the subnet level. In addition, the way allow and deny rules work are different from network access control lists. So again, just think about security groups as a firewall, as a level of security, but as we're in network access control lists, we're security on the subnet level, security groups are security on the instance level. As for the AWS definition, a security group acts as a virtual firewall that controls the traffic for one or more instances. When you launch an instance, you associate one or more security groups with the instance. You add rules to each security group that allow traffic to or from its associated instances. When you modify rules for a security group at any time, the new rules are automatically applied to all instances that are associated with the security group. When we decide whether to allow traffic to reach an instance, we evaluate all the rules from all the security groups that are associated with the instance. So what I want you to take away from that last part there is that if you remember with network access control lists, as they were evaluating the rules from lowest to highest, the second it found a rule that applied, it executed that rule and all the remaining rules were discarded. In the case of security groups, it will always evaluate all of the rules for all of the security groups that are associated with an instance and then decide what to do. So taking a look at our VPC diagram, I want now to insert where security groups lie. So as information comes into the VPC or out to the intranet, if the data is headed towards an instance, whether that is actually an EC2 or an RDS instance, it is going to have to go through a security group. So as data comes into the VPC and flows down through a network access control list into a subnet, before then it gets to the actual EC2 instance, it is going to have to go through a security group. So this is where it lies in the VPC in terms of data flow in and out. In the same manner, when information is leaving an EC2 instance, the first thing it has to pass through is the security group, which can deny information again from leaving the EC2 instance. So between network access control lists and security groups, you have two layers of security between your instances and the outside world. So now let's talk about inbound and outbound rules. So when you create a new security group, all inbound traffic is denied and all outbound traffic is allowed by default. So let's take a look at security groups over here in the EC2 console. So here under Network and Security, click on Security Groups. Now, when you create an AWS account, there is a default security group that is provisioned as part of your VPC. And by default, the default security group comes with inbound and outbound rules allowed for all traffic types. So if I were to create a new security group, we see right away that there are no inbound rules, but there is an outbound rule that allows all traffic out across all protocols and all port ranges. But for inbound, there is nothing by default. So at this point, and we'll move to the next slide here, it is important to understand that all traffic is denied unless there is an explicit allow rule, and there are no deny rules, only allow rules. So everything is denied unless I allow it, and there's no way to explicitly deny something. I can only explicitly allow something. So when I add a rule, let's say an SSH rule, now SSH traffic would be allowed inbound for this particular security group if I were to apply the security group to an EC2 instance. For outbound, everything is allowed, but I can go through and restrict that. I can just change this to SSH, and now inbound only SSH traffic will be allowed, and outbound only SSH traffic would be allowed. So taking a look at this diagram here, if we have in our VPC two instances and two different subnets, and they have two different security groups, one that allows HTTP and that one doesn't, then as traffic would come in from the internet, somebody is requesting information that we have hosted on our EC2 servers. If that is HTTP traffic and it comes in and is directed this way, it would reach the EC2 instance. But if it were to come in this way, it would not reach the EC2 instance. So it is very important when dealing with security groups as well as network access control lists that you're very aware of what type of traffic is allowed, because again, this could become a troubleshooting area when you start to talk about connectivity issues or restriction issues with data flowing in and out of your EC2 instances. So again, to quickly recap, security groups are very similar to network access control lists in that they allow and deny traffic, and I always want you to think about both network access control lists and security groups as your virtual firewalls, as levels of security, and you allow or deny specific types of traffic in or out of your subnets and in and out of your AWS resources that you provision inside your VPC. And best practice is always to allow only traffic that is required. So if you have EC2 instances that are just hosting web traffic, then you should only allow HTTP traffic in and out. There's no reason to allow other types of traffic in and out because that could just open up security holes in your system. So with that, we will complete this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, we are going to focus on IP addressing, specifically IP addressing definitions, conceptual overview of IP addressing, and public versus private IP addresses, which will be the main focus of this lesson. So what is IP addressing? Well, for a simplified definition, is providing an EC2 instance with a public IP address. Now, if you are somewhat unfamiliar with exactly what an IP address is, let's take a look at a simplified definition of that. And that is an IP address is the instance's address on the network. So a quick example of this is think of network traffic as a piece of postal mail. Then think of an IP address as your home street address. Someone trying to deliver mail to your house will need your street address to find your location and deliver the mail. Without a street address, in this case being the IP address, the postal worker would never be able to find your home and deliver the mail. So whenever you think about an IP address, just think about it kind of as your home address. It is the way that people can find you, or in this case, find your instance. So now let's get into public and private IP addressing. By default, all EC2 instances have a private IP address. Private IP addresses allow for instances to communicate with each other as long as they are located in the same VPC or broader private network. So IP addresses are used for internal communication within the VPC. For public IP addresses, EC2 instances can be launched with or without a public IP address by default, depending on the VPC subnet settings. So depending on your VPC subnet settings, EC2 instances can be launched with or without an IP address by default. Public IP addresses are required for the instance to communicate with the internet. So that is very important. So if you want your instance to be able to communicate outside of your VPC, it must have a public IP address. So as another side note, the default VPC and subnets are configured so that any new instance that is provisioned has a public IP address. So that is the default for EC2 instances out of the box, as long as you're using the default VPC. So to recap on this, let's take a look at everything an EC2 instance needs to communicate with the internet. So here we have our EC2 instance, and down here we have the internet. This is everything that it needs and that it goes through in order to communicate with the internet or have data flow in and out to the internet. So you have the EC2 instance, you need a public IP address. Then security groups on the instance have to have rules that allow the traffic in and out. Then at the network access control list level, again, you need rules that allow traffic in and out. The instance needs to be associated with a route table. that route table needs to be associated with an internet gateway, then the data or information can reach the internet or vice versa coming in. But if any one of these items, these components, or these steps isn't configured properly, then information will not be able to flow between the internet and your EC2 instance. So these are all the points of failure, or I should more say the points that you have to look at if you're troubleshooting restriction errors. So it may be that you're trying to access the internet, but you don't have a public IP address. Or maybe your inbound or outbound rules on security groups or network access control lists are not set up to allow that specific type of traffic. Or maybe the EC2 instance is not associated with a route table, or maybe the route table doesn't have an internet gateway attached. These are all areas that you need to look at or think about when you are analyzing your VPC and your internal network in terms of data flow and communication. So again, quickly, IP addressing is providing an EC2 instance with a public IP address. And always think of an IP address as your EC2 instance's address, or its street address. It is how it is identified, and it is how information is delivered to it on the network. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to actually go through the steps of provisioning an EC2 instance. So a step-by-step guide of how to launch an EC2 instance, as well as how to log into the EC2 instance using the SSH protocol. So without further ado, let's get started. So the first thing we need to do is navigate to the EC2 instance console where I already am, and then click on Launch Instance. This is how we're going to launch an on-demand instance. I need to select an AMI, for which I'm going to select the Amazon Linux AMI. We're going to keep everything we do free tier, so I'm going to select the general purpose T2 micro instance type. And here for configuring instance details, we haven't gone through this page yet, but I'll briefly run through these options now. Up top here, you can select to create more than one instance during this process. So if you wanted to create 3, 4, 5, or 10 copies of this instance at the exact same time, you can do that here. For network, this is where you select the VPC that you want to launch into. And for subnet, this is where you can select the subnets or one specific subnet that you want to launch the EC2 instance in. So I want to make sure, since this is going to be a public-facing EC2 instance, meaning that I want it to have access to the internet, I need to launch it into one of my two public subnets, because it's the public subnets that are associated with a route table that has a route to the internet gateway. Here for auto assign IP address, it is going to use the default settings for the subnet, which is enabling auto assign of public IP address, but you can always change that here depending on various settings. For the rest of these, I'm going to leave them as default. However, what I'm going to do next is down here under advanced details. This is not something you have to do. This is an option, but I am going to have it run the following bash script. And what this does is it allows us to run some commands and install software and updates during the configuration process of the EC2 instance. So all this is doing here, these are just some Linux commands. It is going to update the yum installer and then install the Apache web server. Now what this is going to do is it will allow us to test the internet connectivity of our EC2 instance, and I'll show you that when we get to that point later in this lesson. Next, we want to add storage. By default, we must have a root volume. I'm going to leave it as general purpose SSD with a size of 8 gigabytes. But I'm going to add an additional volume just for demonstration purposes to this EC2 instance so that we can then go in later and take a look at how that reflects in the EC2 console. Next, if you like, you can add a tag. You don't have to, but I will put in a value here just so we can give the instance a name. Next, we have to configure our security group. So while selecting a security group for the instance, you can either create a new security group or select an existing security group. For existing security group, we only have the default security group that came with our VPC, in which all traffic is allowed both on the inbound and outbound. But I'm going to create a new security group because I do want to have inbound SSH as an option, but I also want to have inbound HTTP as an option because that is how we'll be able to access our EC2 instance via the public IP address. So now currently, with assigning this security group, these are the only two types of communication protocols that will be allowed through the security group to the EC2 instance. Next, we'll view and launch the EC2 instance. Now, here's an additional security layer that I have not talked about yet, and this is the public and private key pair. This must be used for every instance that you create, and it is required when you want to SSH and log in to your EC2 instance after it has been created. So here's what you need to do. You can either choose an existing key pair or create a new key pair. We currently don't have an existing key pair in this account, so I'm going to create a new key pair. I'm going to give this a name. I'll call it Essentials Key Pair. And I will download this key pair. It's very important. So it is now downloaded to my computer, and I must make a note of where this has been downloaded to, which is just my default download directory. And then next, we want to launch the instance. And then we'll click on View Instance. Now, what's happening now is that Amazon is now launching and configuring this instance for us, and it's going to go through several stages and take a few minutes to be fully provisioned for us. So I'm going to pause the video and come back in about a minute or two once this is complete. Okay, welcome back. The EC2 instance has been fully provisioned and launched and has passed the status checks and is now up and running. So let's take a look at a couple of key components here in the EC2 console. And for that, I want us to look down here. So I'm going to bring this up a little bit. There is some information we can gather down here, one being the public IP address, the private IP address. You can view the security groups here, as well as the availability zone that the EC2 instance has been launched in, the subnet that the EC2 instance has been launched in, and a lot of other information regarding various components of the EC2 instance. So now, since I used this bash script to install the Apache web server on this EC2 instance, we should be able to get the Apache test page if I navigate to the public IP address. So let's give that a try and see what happens. Perfect, here we go. This is the Apache test page. So that confirms that our EC2 instance has been provisioned correctly, and all of the connections, all of the routes between the EC2 instance and the internet, this being actually my computer that I'm accessing it from my office, is all configured, set up, and working properly. So now let's take a look at how to actually log into this EC2 instance. And for that, I'm going to bring in the command line interface or the terminal here. So I'm going to pause the video and reconfigure the screen so we can fit everything on here at once. Be right back. Okay, I'm now back, and as you can see here, I've kind of squished the web browser up a little bit here, and I've made room for my terminal application so I can access the command line. In order to log into the EC2 instance, in this case, the Linux EC2 instance, to get the proper instructions, I can click on my EC2 instance and then click on connect. And what it's going to do is it's going to give me a set of instructions that I need to follow. First is that I actually have to change the permissions on the key pair file that I created and downloaded earlier when I was launching the EC2 instance. And so the command that needs to be run is the chmod 400 command to change the permissions on the essentials key pair.pem file. But first, I need to navigate into the directory that I downloaded the essentials key pair file to. Okay, and there we can see the key pair file, and actually I spelled that with an extra S, so I have to be mindful of that. So now I can literally just copy and paste and run this command to change the permissions. So the permissions have now been changed, and now I need to run this command here in order to log into the instance. If it asks you, are you sure you want to continue? Type yes. And there we go. I am now at the command line logged into this particular EC2 instance. So just to recap, this instance right here, I am now logged in down here and can do with it whatever I wish. Now, to log out of the instance, you can just type exit, and I'm now logged out of the instance. So that's just a quick overview of once you've created and provisioned an EC2 instance or a Linux EC2 instance, that is how you SSH into the Linux instance so you can then do with it whatever you would like. Okay, so I'm now going to get rid of the command line, so I'm going to pause the video and come right back. Okay, so now before I finish this lesson and end this section, let's take a minute to actually experiment a little bit with various connections with the route table, network access control list, and security group to see what happens when I change any of those settings, how it affects my ability to access my EC2 instance from an outside computer, which is what's happening here. So if I shoot over to the VPC section of the console, let's take a look at route tables. So currently, I'm being routed through this route table because the subnet, this public subnet that I launched the EC2 instance in, is associated with this route table. And this route table has the internet gateway attached. So what were to happen if I were to come in here and remove the internet gateway from this route table? Well, my EC2 instance now no longer has a route to the internet. So if I refresh this page here, it's now just going to spin. This is just going to spin, and given enough time, it will just come back with an error. So if I go back now, edit, add another route, put the internet gateway back in, click save. This is still spinning, but if I stop it and refresh, it immediately loads the page right back up again. So the same thing can occur if now I go into network access control lists. Double check here. I believe that this is the network access control list that is associated with this subnet. I can check that by going under subnet associates and see, yep, this public subnet 1 is associated with this network access control list. So I can go into the network access control list, and if I click edit, and if I just remove the rule that allows all traffic inbound, the same thing should occur now. If I go back here to this test page and click refresh, it's just going to spin and spin and spin and not be able to access the test page because the connection now, or the route between the EC2 instance and my office computer, has now been broken inside of the VPC. So I'll go back and fix this. And I'm showing you all this just to reinforce everything that we've talked about so far with VPCs and EC2 instances and all of the routing that takes place internally within AWS and how components or resources inside the VPC are connected to the internet. So the same thing can be applied if I were to go to security groups. So back to EC2. I can click on security groups, and this is the security group that I currently have attached to the instance. And by the way, let's just refresh this again, make sure, yep, that loaded right up again. Now, if I go to inbound rules, I see that I am allowing HTTP into the instance. So an HTTP is the traffic type that is being used when I'm requesting this test page using the public IP address. So if I remove this rule, then I should not be allowed to access the test page. So let's give this a try. I'll just take the rule out. I'll click save, and this should apply immediately to traffic coming in and out of the EC2 instance. So I'll click refresh now. And again, it has not loaded the page. It's just going to spin and spin and spin and spin and eventually load an error. So I can go back. I can add another rule, put HTTP back in, click save, and then refresh this again, and it immediately loaded the page. So this has been now a complete overview of how to launch an EC2 instance, then how to connect to the EC2 instance, in this example using a Linux instance and SSH as the connection protocol, but then also by using the Apache web server as a test platform to test the connection via HTTP protocol from an outside source, so from a computer outside of the VPC. And then we went through and I showed you several examples of how changing or disconnecting the routes via the route table or the network access control list or security groups can prevent connections. So always be mindful if you're having connectivity issues of the possibility of there being issues with your security group access, network access control list rules, and or route tables and internet gateways. So with all that being said, let's take a look at our Project Omega infrastructure requirements. So for this section, we needed a server to host and run Project Omega, and specifically one running EC2 instance using the Amazon Linux AMI. We have that. With Apache server installed, we have that. And verify that we can access the Apache page, which we've done. So great, we have fulfilled all of the requirements for Project Omega in this section. So let's wrap up this section. This was AWS Essentials Section 5, in which we covered Elastic Compute Cloud, otherwise known as EC2. We covered an overview of EC2. We talked about Amazon Machine Images. We reviewed instance type components. We talked about EBS volumes and snapshots, how to use security groups with EC2, IP addressing, public versus private, and finally, we launched and logged into an EC2 instance. So finishing up this section, we can go back to our main diagram, and next we're going to dive into RDS and DynamoDB, which are the database services of AWS. So with that, we will complete this lesson and complete this section. Thank you for watching. You may now move on. Hello and welcome back. We've been moving along quite nicely here, just finishing up S3 and EC2, two of the three what I would call core AWS services. Now let's activate RDS and DynamoDB, and we can jump in here and start to talk about AWS's database offerings. So RDS and DynamoDB, that will be AWS Essentials Section 6. Specifically, we're going to talk about an overview of AWS's core database offerings, a conceptual review of SQL versus NoSQL databases, database pricing overview, provisioning and connecting to an RDS database, and a brief introduction or overview of SSH tunneling. So, without further ado, let's jump into Databases Lesson 1 with RDS and DynamoDB basics. In this lesson, we're going to talk specifically about RDS versus DynamoDB, SQL versus NoSQL, and finish up with a pricing overview of each. So, in the world of databases, there are two main categories. There's relational databases, known as SQL, and non-relational databases, known as NoSQL. Amazon offers services for both types of databases. RDS is for SQL databases, and DynamoDB is for NoSQL databases. Now, if we look over here in the AWS console under databases, you're going to see RDS and DynamoDB. So RDS, let me click on it here. RDS, or Relational Database Service, for an essentials or simplified definition, RDS is a SQL database service that provides a wide range of SQL database options to select from. For example, there are many different SQL options that include Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. So if I click here on Getting Started, we can see here I can select between all these various options, or what are called database or RDS engines. So by clicking on any one of these, I can then select on various options for each. In terms of AWS's definition, Amazon Relational Database Service, or Amazon RDS, is a web service that makes it easier to set up, operate, and scale a relational database in the cloud. It provides cost-efficient, resizable, which is a key component of this, resizable capacity for an industry-standard relational database and manages common database administration tasks. So one of the great things about using RDS on Amazon Web Service is that you don't have to set up and maintain the server yourself. It does that for you on the back end. You are just using this as a service as opposed to having to set up your own server, install the software yourself, and manage the underlying operating system. For DynamoDB, the essentials definition would be DynamoDB is a NoSQL database service, which, unlike RDS, DynamoDB does not provide other NoSQL software options. So with RDS, you had a bunch of different engines that you could choose from. With DynamoDB, this is the only NoSQL software option. And it does replace, or is very similar to, MongoDB, CassandraDB, or Oracle NoSQL. In terms of the AWS definition, Amazon DynamoDB is a fast and flexible NoSQL database service for all applications that need consistent single-digit millisecond latency at any scale, so it's extremely fast. Its flexible data model and reliable performance make it a great fit for mobile, web, gaming, ad tech, IoT, and many other applications. Now, in terms of the difference between SQL and NoSQL, and therefore RDS and DynamoDB, there's just some basic differences you need to be aware of. Now, this is not a database course, so I'm not going to go into the nitty-gritty of each, but if you're trying to figure out which one you may want to use, or this is more to give you a general understanding of what is what, RDS, or SQL database structures, stores related data in tables using columns and rows. So very much a traditional database setup. And that's typically used for structured data such as a contact list. Whereas DynamoDB, being NoSQL, this stores related data in JSON-like name value documents. typically used for non-structured data such as cataloging documents. So there's really a large difference in the way that these two databases store their information. And again, in the constructs of this AWS Essentials course, I'm not going to go into any more detail about the two. So moving on, let's look at the pricing and cost overview for RDS and DynamoDB. For RDS, there is free tier use available, but it's only available for all RDS options except Aurora. So if you do want to use RDS and use the free tier option, you cannot use Aurora. You must select one of the other engines. So how are you charged for using RDS? Well, pricing depends on, one, the engine that you choose. So whether you choose Amazon Aurora, MySQL, MariaDB, and so on. Next, the instance class. Now, this is very similar to what we talked about with EC2 instance types. So this is your processor, your RAM, all the various components that make up the hardware that is going to run the database. Also, purchasing terms, very much like EC2, you have on-demand and reserved databases. Database storage, the amount of storage that you need. The IOPS involved with the storage. Also, data transfer in and out of RDS. And as always, make sure to check out this link here before you do any major use of RDS to make sure that you understand what you are being charged for. Moving on to DynamoDB, there is free tier use available, and for DynamoDB, you are charged for the provisioned throughput capacity that you require, indexed data storage, DynamoDB streams, reserved capacity, and data transfer in and out of DynamoDB. And again, you should make sure to fully understand the cost and pricing structure by going to DynamoDB pricing before you do any heavy lifting in DynamoDB. So to sum up again, one thing that I really want you to take away from this is that for database offerings, there are two. There is RDS and DynamoDB. RDS is for relational or SQL databases, and DynamoDB is for non-relational or NoSQL databases. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we're going to focus specifically on provisioning an RDS database, touching on topics that include private subnets and SSH tunneling, how to launch an RDS MySQL database, how to connect to an RDS MySQL database, and then lastly, again, a Project Omega requirement check, since this will be the final lesson for this section. So to get started, let's just conceptually understand what we're going to do here. Let's say that we have our dev team, and once we have the RDS database set up, they are going to need to be able to access it. And they're going to need to do that from their work computers in the office. So it's going to be computers, or they're going to need access to the RDS database from computers that are outside of the VPC. So they're going to be coming in through the internet. But one of the interesting things that we've been talking about up to this point is that we're going to launch an RDS instance in a private subnet. Now, a private subnet, up to this point, we've always stated, does not have a route to the internet, meaning that people using computers out on the internet can't get access to instances in a private subnet, and vice versa. Information in a private subnet can't go out to people on the internet. So there is a way to work around that, to have a special way to get into private subnets, and that is called SSH tunneling. So what we're going to do here is we are going to create a tunnel through our public subnet and through an EC2 instance to the RDS instance in a private subnet. And the reason we can do that is because we are going to publicly connect to our EC2 instance, the one that we created in the last section. But then once connected to the EC2 instance, we are going to connect internally through the EC2 instance to the RDS instance. And you can do this because if you remember, regardless of whether or not a route table has an internet gateway associated with it, internally, all instances can talk to and communicate with each other regardless of whether or not they're in a public or private subnet. So we're using the EC2 instance as a pathway to reach an RDS instance in a private subnet, and this is called SSH tunneling. Okay, so now let's move on to actually configuring and launching our RDS MySQL database. The first thing we actually need to do is to create a subnet group. So we need to identify our two private subnets and isolate those into a group that our RDS instance is going to be provisioned into. So I'm going to click on subnet groups here and create a subnet group. I'm going to give this a name. I'll call it Essentials Subgroup. Description, I'll just copy and paste. VPC, we have only one VPC, so I will select those. For availability zones, now I need to select the two availability zones that our private subnets are in. So I'm actually not sure, I don't remember exactly which one they are in, so we can just open up in another tab the VPC section and go take a look and verify which availability zones our two private subnets are in. So I'll click on subnets. Let me just sort here. So private subnet 4 and private subnet 3, those are the two subnets that we want, and those are in availability zones 1D and 1E. So I can click on 1D, select the subnet, add that to the group, and then select 1E, and select that subnet and add it to the group. Okay, perfect. Click create. Now that we have our subnet group created, we can go back to instances and launch our database instant. Going to select MySQL. And if we want to use free tier, which we do in this case, you need to select the dev test MySQL option. Anything else, anything for production, you are going to be charged for. Okay, so now a nice thing that they offer here is the ability to click this toggle here, and it will only limit these options to those available for RDS free tier. So it already pre-populated this part with things that we can use without being charged. We do, however, have an option for instance class, and instance class is very similar to EC2 instance class in that you are selecting the CPU and the hardware configuration and RAM for your instance. In this case, it's a database instance, so I'm going to select this one here. Storage type, general purpose SSD, that's fine. The allocated storage is fine. I then need to give the database a instance identifier, a username, and a password. So I'll call this Essentials Database. I'll give the username of admin and the password. Very important that you remember or record the username and password for your database instance, because this is what you're going to be using to log into it. Go to next steps. For VPC, this is the VPC that we're using. That's the only one that's selected. For subnet group, make sure to select the subnet group that we just created. For publicly accessible, we want this to be set to no, because again, if we were to put publicly accessible on this, that would give it a public IP address. And we don't want this to have a public IP address. We're only going to be communicating internally with this particular RDS instance. For availability zone, you can select no preference because it's going to choose an availability zone based on the subnets that we have in our subnet group. And then for VPC security groups, one of the things you have to be very careful of here is that RDS communicates over port 3306. So that means that a security group that you assign to this RDS instance needs to have that port open. So if I just click on create a new security group here, it will create a new security group for me with 3306 as an allow option. So next, I will give the database a name. I'll use the same name that I did earlier for the identifier, which was Essentials Database. And then looking down through here, we'll just leave the rest of these options as default. So now let's launch the database. And we'll click on View Your Database Instances. Now this is creating, and this is going to take a while. This can take anywhere from 5 to 10 minutes or longer depending on what you have provisioned. So I'm going to stop the recording at this moment and come back when this is complete. Okay, I am back, and as you see here, our RDS MySQL database is now available. So let's click on it and take a look at some of the information that it provides to us. So first, let's click here on this tab, and this is where you're going to find a bulk of the information for your database, including many of the options that we chose when we were launching the instance itself. One of the things that you want to note down here are the endpoint and port, because we're going to need those in order to connect to this in a second. And one of the things that you really have to know about using RDS instances is that there is no GUI in the AWS console. You have to use third-party software to log in and actually use the databases. So I'm going to show you how to do that now as we move into the next slide of this section. So I'm going to again pause the video because I'm going to bring in another application to our screen. Okay, so I'm back, and what I've done here is obviously here I have our Project Omega interactive guide document. On the left side here, this is still the AWS console up here, and I will be using this to kind of jump in and grab some information as needed. But this down here is MySQL Workbench, which I have downloaded and installed on my computer. And this is what is needed in order to access RDS MySQL databases, specifically the type that we launched. Now, if you decide to go in and launch a different database in RDS, then that may require a different piece of software, and instructions will be within each one of those sections in AWS if you decide to do that on your own. But for this example, we're using the MySQL RDS database, and that requires MySQL Workbench, or at least that is the most popular option to use to log in. So I open MySQL Workbench, and I need to set up a new connection in MySQL Workbench. So I'm going to click on this right here to open a new connection. And I have to give the connection a name. So Essentials RDS, I'll call it. For connection method, we want to select standard TCP/IP over SSH. This is what is going to allow us to do the SSH tunneling. So if you remember, this is what we are now setting up, this tunnel through this EC2 instance. So now that we have our connection method selected, we have to put in the host name, the SSH host name, and this is going to be the public IP address of the EC2 instance that we're going to use to tunnel through. So I have to go back to the AWS console. I have my RDS tab here. This is the VPC tab, but I'm going to back out of this and go into EC2, and I'm going to grab the public IP address of my running EC2 instance. Instances, there we go. Refresh the page. Here is our running instance, and here is our public IP address. So I'm going to grab that, copy it. I'll shrink this back up, and I'll input that here. For SSH user, now this we have not covered yet, but I'm going to jump in and do that now, switching back over here to the AWS console. So back to the instance. Now, when you go to connect to an instance, and remember in the previous section on EC2, we used this command to log in to SSH in to the EC2 instance. Well, if you look at this command closely, this is actually the username right here, or this is the default username. So this is what I need to grab. And I'm going to put that right here. There is no password for the EC2 instance, but I do need to provide the SSH key file. This was the .pem key file that we had to use the chmod command on when logging in to the EC2 instance. So I'm going to find that on my computer, which is right here in my downloads, and click open and OK. Or not OK yet, but just click open, and there it is. Next, for my SQL host name, this is now where we need to go back up here, back to the RDS side, and this is where I'm going to grab the writer endpoint. So this right here, I'm going to copy that to my clipboard and paste that right here in the host name. For MySQL Server port, we'll leave that as 3306. For username, I now need to put in the username that I used when I created the RDS instance, which was admin. And then for password, I'm going to click to store in keychain, and this is going to be the password that I created when I created the RDS instance. And we'll click OK. And now that we have all of our information set, what I want to do is test the connection. Okay, and we'll give this a second as it is testing out this connection. Whoop. Uh-oh. Okay, so we have a bit of an issue here. We got an error which said that it failed to connect. So whenever we see a failed to connect issue, the first thing that we want to do is reevaluate or take a look at our security groups, network access control list, route tables, and internet gateway. Make sure that all of those are working correctly or have the right routes and ports open for our data to flow and communicate correctly. So let's jump back over here and take a look. We'll start with security groups. Go back over to EC2 and let's take a look at security groups. So looking at this, let's first look at the security group that we have associated with our RDS instance, which is this one right here. And to double check that, you can always go back to RDS and you can look and see security groups here, RDS Launch Wizard 1. So RDS Launch Wizard 1, let's take a look here. Okay, so for inbound, we have MySQL Aurora as the type, TCP, the proper port. Okay, here's what's going on. When AWS automatically created the security group for us, it restricted the source data to only this IP address. Now, since I'm trying to log in from my personal computer, that has a different IP address than this. So it's rejecting it because the source IP address is not the same. So all we need to do, and this should work, is just to change this to all sources. We'll click Save. Okay, and we'll jump back over here and let's test this connection again and see what happens. Hey, successful. We made our MySQL connection. So perfect. Then we'll click OK. And now we have a working connection. And here we go. And this is how you will use and manipulate the RDS database. So now jumping back to over here, we have finished the basic steps for connecting to an RDS database. And just to recap, we are using SSH tunneling. So right now, this connection here to the database is me sitting at my computer outside of the VPC, going over the internet, in through the internet gateway, through the route table, through the network access control list, through the security group, into the EC2 server. Then the EC2 server is then communicating through another route table into the private subnet of our RDS instance. And then the information is coming back out the exact same way. So, before we complete this lesson and section, let's take a look at our Project Omega infrastructure requirements. And for this, we needed a database to store and catalog data. We needed an active RDS MySQL database with a verified connection status. We have that. The database must be in a private subnet and accessible via SSH tunneling. We have also done that. So perfect. We have fulfilled all of the requirements for Project Omega. So to recap, in AWS Essentials Section 6, we learned about RDS and DynamoDB. We had a nice overview of AWS's core database offerings. We conceptually talked about SQL and NoSQL databases. We went over some database pricing, options, and overviews, and how to provision and connect to an RDS database using SSH tunneling. So now back to our main diagram. We are really starting to fill this in. And next, we are going to move on to SNS. So with that, I will conclude this lesson and conclude this section. Thank you for watching. You may now move on. Hello and welcome back. Now that we have completed covering what I would consider the core 3 services of AWS in S3, EC2, and RDS/DynamoDB in the way of databases, now we're going to move on to some of the other services provided by AWS, which I feel are very important and are extremely useful while using, monitoring, and maintaining your AWS account and any architecture or software that you decide to deploy in it. So first, we're going to take a look at SNS. So let's dive on in. So this is AWS Essentials Section 7, covering Simple Notification Service, more commonly referred to as SNS. We are going to cover an introduction to SNS, cover SNS conceptual overview, how to use SNS, including how to create a topic, add subscriptions, and send messages. So let's get started with Lesson 1, SNS Basics, where we're going to cover SNS definitions, a conceptual overview, SNS workflow and components, and cover a pricing and cost overview. So first, let's start with what is SNS? The Essentials definition is an AWS service that allows you to automate the sending of email or text message notifications based on events that happen in your AWS account. For the AWS definition, Simple Notification Service is a web service that coordinates and manages the delivery or sending of messages to subscribing endpoints or clients. In Amazon SNS, there are 2 types of clients, publishers and subscribers, also referred to as producers and consumers. Publishers communicate asynchronously with subscribers by producing and sending a message to a topic, which is a logical access point and communication channel. Subscribers, i.e. web servers, email addresses, Amazon SNS queues, AWS Lambda functions, consume or receive the message or notification over one of the supported protocols, i.e. Amazon SQS, HTTPS, email, SMS, or Lambda, when they are subscribed to the topic. So, in a nutshell, Simple Notification Service is a notification service. And specifically for the Essentials part, we're just going to focus on sending email and text messages based on events that happen within your AWS account. So let's take a look at some SNS usage examples or workflow. So let's say, for example, we have an EC2 instance, and right now that EC2 instance is working just fine, which means that there's no need for action. But what happens all of a sudden if the EC2 instance crashes? Well, if there's nothing in place to notify the system administrator, then the system administrator would never know. And this is where SNS comes into play in conjunction with the service that we're going to talk about in the next section, which is CloudWatch. But setting things up, what happens is that when an EC2 instance crashes, you can set up CloudWatch so it is constantly monitoring your instances. When it detects that an instance has crashed, it can trigger an alarm. That alarm can then trigger a notification in SNS, and then SNS sends a message to the system administrator. The system administrator then gets alerted, can then go in and fix the server, and then everything will again be well. So this is basically the workflow and how SNS, which we're talking about now, and CloudWatch, which we're going to talk about in the next section, work together in order to monitor the resources inside your AWS account and send you notifications based on thresholds, metrics, or things that you set up to be triggers for the alarms and notifications. Taking a look at basic SNS components, there are three things that I want you to concentrate on here. First, we have topics, and this is how we label and group different endpoints that you send messages to. The next are subscriptions, and these are the actual endpoints that a topic sends the messages to, i.e. the email address or phone number of our system admin. And then publishers are the human, right? It would be me or the CloudWatch alarm or whatever event that gives SNS the message that needs to be sent. So generally what we do is we create a topic, and the topic can be EC2 failures. Then for subscriptions, that would be whoever we want to send the message to, being the actual endpoint itself, being the email address of the system admin or the phone number. Then the publisher will be the message that gets sent. So it could be an automated publisher, or it could be actually me sitting at a computer typing the message and hitting send to the topic. But whether it's a CloudWatch alarm or a human that types in a message, we send that message to the topic, and then the topic then sends it to the endpoints. So let's take a quick look at pricing. Free tier use is available for SNS, and you are charged for using SNS by publishes, meaning the number of SNS requests, i.e. the message that needs to be sent. Notification delivery, so the number of subscribers the message is sent to, and the data transfer in and out of SNS. And as always, before doing anything major with any AWS service, you should always review the detailed pricing information on Amazon's website. So again, to review, simple notification service is just that. It is a simple notification service, and to use it, at least at its base level, is very easy to set up, and we are going to cover that in the next lesson. So with that, I will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to focus on actually using SNS, and we're going to cover specifically how to create a topic, add subscriptions, and send messages, as well as looking at our Project Omega requirement checks for this section to make sure we're covering everything that we need to. So jumping in, let's take a look at how to create a topic. So first, in the AWS console, we have to navigate to the SNS service, and that is here under mobile services under SNS. So the first thing we want to do, if you've never used this service before, is click on Get Started. And now once here, the first thing we need to do is click on Create a Topic. We're going to give this topic a name. We'll call it Essentials SNS Billing, since I'm going to eventually turn this into a billing notification. Now for display name, you only have to enter a display name if you're going to use SMS endpoints. So I very well may use SMS endpoints for testing this out, so I'll just put in a brief description. I'll just call this billing. We can create the topic. So that's all you have to do for creating a topic. It's very simple, but now we have to add subscriptions. So these are going to be the endpoints that we want to send messages to. And we do that now by being in our topic and then clicking on Create Subscription. So the first thing I want to do is select the protocol, and these are the different protocols that are available for various endpoints. So first, I just want to select an email protocol, and then I'm going to insert the email that I want to add as a subscription. So I'll use the email that I have set up here, which is the one that I used to create this AWS account with, and that is the la.aws.essentials@gmail.com. All right, did I spell that correctly? la.aws.essentials@gmail.com. Okay, let's create the subscription. Now, when you create a subscription, in order for any messages to then work when we go to publish a message, the subscriber that we have added to this topic has to subscribe themselves. They have to authorize the subscription. So if we now look under my email account, I see an email that has come in saying AWS notification subscription confirmation. So what I need to do is click this link to confirm. Very much like you may receive an email from somebody or accept that you're going to receive emails from somebody. That's what is happening here. But before I do that, back in the SNS console, I see that for this subscription ID that it is pending confirmation. So if I have a long list of subscribers here, I can always look here to see who is subscribed and who I may be waiting on to still accept the subscription. So I click confirm subscription. I get a confirmation that I have been subscribed. And back here, if I refresh, it is now going to have that as confirmed, and I have now added myself to this topic. Now, if you wanted to add an additional subscription, say a phone number, so that the topic will send messages to a phone via text message, you can create another subscription, click on SMS, put your phone number in here, following this format, click subscribe, and then you will follow through the same process as before. But I'm not going to go in and add my phone number now. But now let's actually test publishing to the topic. So sending a message to this email. Now doing this manually, I can just click on publish to topic, and I can put in a subject test, and this is almost just like sending an email. I can put in a message, essentials SNS test, and then click on public message. And then right here on my email, I see that that came through. So it is the billing topic, and it is SNS Essentials Test. That's the body. And there we go. I've sent myself a message through AWS's simple notification service. So it's really just that simple to create a topic, add a subscription, and then publish to the topic manually. But then it's also very easy in other AWS services to use SNS as a means of delivering a message. So as we move into some of the remaining sections of this course, we are going to, in those other services, set up triggers to trigger SNS topics to send messages to our endpoints. So now let's take a look at our Project Omega infrastructure requirements for Section 7, and here we need a way to send notifications, email or text messages to Project Omega's team members based on events that may occur with Project Omega's infrastructure. So we want one topic set up with a billing alarm with email as an endpoint. We have done that, but then also one topic set up for an auto-scaling alarm with email and SMS as endpoint. Okay, so let's walk through that process. We have to create another topic for ourselves. So I can go back to topics, click on create a new topic, and I'm going to call this auto scaling group alert. Alert. I'll give it a display name. We'll choose the same display name, and we'll create the topic. So I will now choose this topic. And now I'm going to add two endpoints, my email address again, and an SMS. So create subscription, email, create subscription. Then I'm also going to create another subscription, this time SMS. And you want to make sure to use this format. If you don't use this format, then it may not work. And create subscription. Now, pending confirmation on the email, so let's go back into our email and we will subscribe to this. Confirm subscription. And for SNS, it is already subscribed for us, which actually that must be new. Generally in the past, I've always had to confirm the SMS subscription as well. So let's see if this actually works. Let's publish to this topic and see if I receive a text message. Okay, there we go. I just received a text message to my phone from that topic, and that came through just fine. Okay, so perfect. Everything is set up correctly, and we are now ready to proceed. So, as we finish this lesson and this section, let's just do a quick review. This was AWS Essentials Section 7, in which we learned about simple notification service. We had an introduction to SNS. We learned about SNS's conceptual overview and how to use SNS, including how to create a topic, add subscriptions, and send messages. So looking back to our main diagram, we can see that we are starting to fill a lot of it in and getting closer to the end. And next we're going to move into AWS CloudWatch. So with that, I will conclude this lesson and conclude this section. Thank you for watching. You may now move on. Hello and welcome back. As we have just finished the section on SNS, in which we learned about how to send messages using the simple notification service, we are now going to move into CloudWatch, which goes hand in hand with SNS in allowing us to monitor and receive alerts and messages when certain events within our AWS account occur. So without further ado, let's turn on the CloudWatch section and dive in. So AWS Essentials Section 8 focuses on CloudWatch. We are going to have an introduction to CloudWatch, have a conceptual overview of CloudWatch, have a pricing and cost overview, talk about metrics and alarms, and finally, using alarms to trigger SNS topics. Starting with Lesson 1, we are going to focus on CloudWatch basics, specifically CloudWatch definitions, conceptual overview of CloudWatch, CloudWatch components, and pricing and cost overview. So to start with some definitions, let's talk about what is CloudWatch. For an essentials definition, CloudWatch is a service that allows you to monitor various elements of your AWS account. For the AWS definition, Amazon CloudWatch monitors your Amazon Web Services resources and the applications you run on AWS in real time. You can use CloudWatch to collect and track metrics, which are variables you can measure for your resources and applications. CloudWatch alarms send notifications or automatically make changes to the resources you are monitoring based on the rules that you define. So basically, CloudWatch is the way that we can monitor the resources that we launch and provision within our AWS account, and then we can set things up to either notify us or automatically take action depending on the metrics and certain thresholds that we may put in place on those metrics. So now let's talk conceptually about what CloudWatch can do. You can use CloudWatch to monitor various metrics from other AWS services and resources. For example, we can use CloudWatch to monitor EC2 instances. We can view metrics such as CPU utilization, status checks, disk read and write operations. For S3, the number of objects in a bucket or bucket size. And there's also ways to monitor billing, to monitor our monthly bill. And there's a really nice feature that we can set these metrics up with widgets on a dashboard. And we do that over here in the AWS console by using CloudWatch under Management Tools. Now, the next lesson is going to be more hands-on, and we're going to dive in on how to use this, but for now, we'll continue on with our conceptual overview. And based on the metrics, we can set thresholds to trigger alarms. So if, say, for EC2, we can set a metric threshold if CPU utilization is greater than 80%, then alert us, trigger an alarm. We can do the same thing for S3. We can choose a metric and then set a threshold on it. And also something that is extremely valuable is that for our current monthly bill, we can also set a threshold on that. So say that we want to be notified if our current monthly billing goes above $500 or hits $500, we can set up an alarm for that. And when our current monthly bill hits $500, then we can, say, trigger an SNS topic to send us a text message or an email that says, hey, your monthly bill has hit $500, then perhaps maybe I want to go in and take action and delete or terminate some of my resources so that I don't continue to incur charges for the month. So CloudWatch is a great way to be able to monitor all aspects of resources that you provision inside your AWS account and make sure that everything is being utilized properly. So let's talk quickly about pricing and cost overview. So there is free tier use available for CloudWatch, which is great. Now, in terms of how you are actually charged for using CloudWatch, you are charged per dashboard. You can have multiple dashboards with many metrics on each. There is both regular and detailed monitoring, and you do get charged extra for detailed monitoring for EC2 instances. You also charge for Amazon CloudWatch custom metrics, so you can create your own metrics as opposed to the ones that they will have already made for you. CloudWatch API requests, CloudWatch logs, and CloudWatch events or custom events. Now, again, pricing does vary depending on the region that you may be in. And as always, before doing any major usage of CloudWatch, be sure to follow this link here and read up on specific pricing details, because as with a lot of AWS services, using it a little bit can generally be very inexpensive. But if you're going to start to use something a lot, you need to make sure to have a full understanding of what you are being charged for. So again, to sum everything up, CloudWatch is the way that we internally monitor our AWS resources and various aspects of our account, and it allows us to view the metrics, place thresholds on the metrics, and then create alarms which can trigger SNS topics or alert us internally in the console here when those thresholds have been hit. So with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to focus on CloudWatch metrics and alarms, and specifically using CloudWatch to create a CloudWatch dashboard. And then we're going to explore metrics and adding widgets to the dashboard, how to create alarms, and lastly, how to create alarms that trigger SNS triggers. So first, let's take a look at the CloudWatch console here and learn a little bit about the navigation and how to find everything. So on the left side here, you have where you can find your dashboards, alarms, events, logs, and metrics. So let's start by going to dashboards. So we can create a dashboard by clicking Create Dashboard. We'll give this a name. We'll call it Essentials Dashboard. And next we can select a widget type to add to the dashboard. For this particular example, I'll just select a line metric. So now what we need to do is actually select the metric that we want to create the widget for. So let's take a look at EC2 metrics. But one thing that we should know is that these metrics are populated based on resources that we currently have provisioned within our AWS account. So there are more metrics available for other services, but we just don't have any of those services currently active or provisioned in the account. So let's take a look at EC2 metrics per metric instances. And what we see here is this is broken down by instance name on the left side or instance ID. And then there are the metric names that we can take a look at. So let's focus here on our Essentials EC2 instance, and there's the instance ID for that, and then on the metric CPU utilization, because this is a metric that is very commonly used for EC2 instance monitoring. So we can see here over this given time period, and you can switch between the CPU utilization for this instance. Now, the CPU utilization is very low because after I provisioned this instance, we really haven't been using it. But you can see some of the more heightened activity, and this is times when I may have recorded other videos in this course in which I was accessing the EC2 instance. So let's say that I want to set the utilization to a time frame of 1 day. So this is the past day. I can look at the past 3 days, the past 1 week, and obviously this instance has only been created for a few days, so having it be this long doesn't make sense right now. So let's just go back to the last day, and I'll click Create Widget. So now on my dashboard here, I have this widget that I can resize if I want, and I can create and drop in a bunch of other widgets on this dashboard, and I can categorize them so that if I want to monitor many different resources or services of AWS, I can create different dashboards for them and then put specific metrics in. So I can always come back and have these dashboards created and pre-populated for me, so I can always come here and view the metrics to monitor what is going on within my AWS account. Now, in terms of creating alarms, alarms are where we're going to set a threshold and then get an alert based on the alarm. So let's say that for this instance, for CPU utilization, I wanted to get an alarm anytime CPU utilization went above 0.04%. So I can set an alarm, and anytime the utilization would spike up above that threshold, it would show up here as an alarm. So let's take a look at how to do that. If I go to alarms, I can click Create Alarm. Again, I can go to EC2 per instance metrics. I'll go to the same instance, the Essentials EC2 instance, and find CPU utilization again. I'll click on that, and then I'm going to click Next. So now is where I set my alarm threshold. So I'll give this a name, and I'll call it Essentials EC2 CPU Alarm. Description, I can just copy and paste it, make that the same thing. Now here is where I actually set the threshold. So I want this alarm to trigger whenever CPU utilization is greater than or equal to, less than or equal to, or greater than or less than. So I'll put greater than or equal to. I'm going to make this extremely low just so we can have this trigger. I'll just put 0.005%. So it's extremely low, and I'm just doing this for the purpose of having this alarm automatically trigger for one consecutive period. So you set the period down here, and that means that in order for the alarm to trigger, it has to be above the threshold for this many consecutive periods of 5 minutes. So this would just be one period of 5 minutes that the CPU utilization is greater than or equal to 0.005%. So you can change this to day, hour, minutes, and then obviously if you wanted it to be, say 5 days or a week, you could put 1 day, and then 7 for 7 consecutive periods of 1 day. That would equal 1 week. That CPU utilization would have to be above that threshold before it would trigger the alarm. For this example, let's just do 1 minute. For statistics, you can change from standard to custom, and you can set it to average, maximum, minimum, sum, or data samples. Now for actions, this is where you state what you want this alarm to be. Now it can be an alarm, or it can also be something that says, hey, if it's within this threshold or hits this threshold, then the state is actually okay. So it can be something bad, meaning that you want to be alerted that this is bad, that you need to go in and fix something, or you can just have it set up where it says, hey, if it's within this threshold range, then it's actually a good or an okay state. Next, for send notification to, this is where you can set it to notify or trigger your SNS topics. So I can, for example, set this to my ASG alert SNS topic, and you can see the email list, the subscribers that are part of that. And when I hit create alarm, the first thing you're going to see is that it's going to fall under insufficient data. And this is because it hasn't had enough time yet to determine if the threshold has been met or not. So this is going to take a minute or so in order to gather the information and then make a determination whether or not it should be a triggered alarm or not. So while that's processing, let's talk specifically about billing alarms, because this is something that you should probably definitely set up on your account. So clicking on billing alarms, the first thing it's going to say is that no billing metrics found. To get started, please visit the account billing console. So click on preferences in the left navigation pane, and then click on receive billing alerts. So let's walk through that. I'm just going to open up the account console. And you can also find that by just going up to your name here and clicking on my account. We then want to go to preferences and then click on receive billing alerts and hit save preferences. So this is going to turn on our ability to monitor our account billing. So back here, if I now click on billing again or refresh, it is now changed and I can create a billing alarm. So now, if you follow these instructions, basically what it's telling you to do is that when my total AWS charges for the month exceeds, let's just say $10, say we want to keep it very low since we want to use this account for primarily free tier, I want to be notified anytime the monthly billing charges exceeds $10 so that I make sure that I'm not being charged a lot of money for using AWS. So I can set that to 10 and I can send this to my Essentials SNS billing SNS topic. And now when I hit create alarm, anytime that our current monthly billing reaches $10, I'm going to get messages from the subscription endpoints that I have in this SNS topic. Okay, so now here we see that both alarms have a status of okay. So that means that the threshold is not being currently met on either one of these two metrics. So for billing, obviously we have not gone above $10 in estimated monthly charges for this month, so that's okay. And the same thing for the CPU utilization on our EC2 instance. And if I click on that, we can see here, and it says that one data point of 0.0 was not greater than or equal to the threshold of 0.0005. So right now, I guess there is absolutely zero utilization on that particular EC2 instance, so it is not triggering the alarm. So now let's take a look at our Project Omega infrastructure requirements for this section. So we needed a way to internally monitor parts of Project Omega's infrastructure. One CloudWatch billing alarm configured to trigger the SNS billing topic when the current monthly AWS charges reach $10. And we've done that. We've set that up and we have that right here. This other alarm that I set up was just for demonstration purposes. So with that, we can finish this lesson and let's sum up what we learned here in this section. And this was section 8, CloudWatch, in which we focus specifically on an introduction to CloudWatch, a conceptual overview of CloudWatch, pricing and cost overview. We talked about metrics and alarms and using alarms to trigger SNS topics. And as we've just concluded, what I would consider are two kind of hand-in-hand monitoring and alert services for AWS, we are now going to move into two services that have to do with high availability, fault tolerance, scalability, and elasticity. And we're going to start that in the next section when we talk about ELB, or elastic load balancing. But for now, that will conclude this lesson and conclude this section. Thank you for watching. You may now move on. Hello and welcome back as we start another section here in AWS Essentials. As we've now moved on from our monitoring and alert services, we are now going to focus on scalability and elasticity within our AWS architecture. And we'll start that with talking about elastic load balancing. So for AWS Essentials Section 9, the focus will be classic elastic load balancing. We're going to focus specifically on an introduction to elastic load balancing, a conceptual overview of elastic load balancing, benefits and elastic load balancing use cases, cost and pricing overview, how to create an elastic load balancer, and also elastic load balancer security. The first lesson, focusing on classic elastic load balancing basics, will cover ELB definitions, conceptual overview, data flow in the VPC, benefits and use cases, and a pricing and cost overview. So starting out, elastic load balancing, or abbreviated as ELB, for an essentials definition is an ELB evenly distributes traffic between EC2 instances that are associated with it. For an AWS definition, a load balancer distributes incoming application traffic across multiple EC2 instances in multiple availability zones. This increases the fault tolerance of your applications. Elastic load balancing detects unhealthy instances and routes traffic only to healthy instances. So conceptually, let's take a look at how this all works. Again, here's a picture of our VPC diagram. And as there are customers that may want to access our application that we are hosting in AWS, let's, for this example, say that we're hosting a website. So we have two web servers which are hosting our website files. As customers request our website, their request will come in through the internet, through our internet gateway, and they're going to come to the elastic load balancer, and the elastic load balancer is going to take a look at both of these web servers, and it's going to see how many users are currently on each one, and it's going to distribute traffic to make sure that the amount of users on both instances are equal. So taking a closer look at exactly what's happening under the hood, as the requests come in from the intranet, hit the elastic load balancer, the elastic load balancer will decide which server to send the traffic to. It will then go through the route table, which will then direct the traffic through the network access control list, through the security group, and to the server. So I just kind of want to bring in both the elastic load balancer and the route table, because on a lot of diagrams to this point, because of size issues of the diagram, I've not had them both together on the same diagram, but I want you to see here how they work together. Now for an example, let's say that we have 6 users that all want to access our website, and we have 2 web servers set up behind an elastic load balancer. What would occur is that as each user comes in and requests access to our website, the elastic load balancer is going to evenly distribute them between the 2. So this prevents one server from becoming overloaded and potentially crashing. And that, in its very simplistic form, is what an elastic load balancer does. Now for a quick pricing cost overview, it is important to note that free tier use is actually not available for elastic load balancing. You are charged for each hour or partial hour the load balancer is running in your account, and for each gigabyte of data transferred through the load balancer. Again, prices will vary depending on region. And again, before you do any major use of elastic load balancing, you should always check out the detailed pricing guide on Amazon's website to make sure you have a full understanding of what you are being charged for. So to sum everything up, when you think about elastic load balancing, just think about evenly distributing traffic between multiple instances that you have set up in your account to run whatever application you are using the EC2 instances for. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello, and in this lesson, we are going to focus on creating a classic elastic load balancer, touching specifically on how to create the classic elastic load balancer step-by-step walkthrough, and elastic load balancing security groups and communication protocols. So to get started, let's view where to access and create elastic load balancing in the AWS console, and that is done under EC2. In the EC2 console, if you scroll down in the left-hand navigation bar, you will see load balancing. So we can click on load balancers. And the first thing we'll want to do is click on create load balancer. Now, there are two different types of load balancers, application load balancers and classic load balancers. For the purposes of this course, we're just going to stick to classic load balancers. So for basic configuration, we do have to give our load balancer a name. So I'll call this Essentials ELB. Next, you'll want to select the VPC to launch the load balancer in. I only have one VPC, so I'll stick to that. This is going to be an external load balancer, so we have no need for it to be internal. And what's very important here with elastic load balancing security and communication protocols is that you select the proper protocol for the type of traffic that the load balancer is going to be handling. Since this is going to be set up to handle web traffic, we want the communication protocol to be HTTP over port 80, which it is. So next we can assign security groups. And this, very much like a security group on an EC2 instance or an RDS instance, we need to have both proper inbound and outbound rules on the security group that is going to be applied to the elastic load balancer. So for argument's sake here, let's create a new security group. We'll call this ELB security group. And I'm going to want to make sure that I assign HTTP and port 80 as the protocol. Now, for health checks, this is an added benefit to using an elastic load balancer, and we touched on this in the AWS definition in the previous lesson. If an elastic load balancer detects that an EC2 instance is no longer healthy or is no longer available, then it is no longer going to serve traffic to that EC2 instance. So this is where we set up the parameters which will determine whether or not the elastic load balancer deems an EC2 instance healthy or not. For ping protocol, we can set this to TCP. Since we currently don't have an active website set up, we do not have an index.html file for the elastic load balancer to check against. So we're just going to use a TPC check so that it can ping and make sure that the EC2 instance is there. We can then, under advanced details, set the response timeout, the interval, then the unhealthy threshold, and the healthy threshold. So these are the amount of health checks you either have to pass or fail to be deemed healthy or not. So next, we'll click to add EC2 instances. So here is now where you could add or associate EC2 instances that you have with your elastic load balancer. So the EC2 instances you would select here would be the instances that the elastic load balancer would send traffic to. Now, I'm actually going to leave this empty for now. I'm not going to add any EC2 instances because I'm going to use my elastic load balancer as part of my auto-scaling group in the next section. So we will circle back around to actually assigning EC2 instances to the Elastic Load Balancer, but that will be done via an automated process through auto-scaling. So next we can add tags if we like. I'm going to leave this blank for now, but this is something you can do if you wish, and I will review and create. Okay. And now just like that, I have my Elastic Load Balancer. And down here, as with many other services in AWS, you have a lot of information about the components of Elastic Load Balancing. You have instances that are associated with the Elastic Load Balancer, as well as the health checks that you have set up, in which you can always go through here and edit the health check parameters. So that is a general overview of how to create an Elastic Load Balancer, and we are going to revisit Elastic Load Balancing a little bit in the next section when we move into auto-scaling. But for now, let's wrap up this lesson and this section, in which this was AWS Essentials Section 9, in which we learned about classic Elastic Load Balancing, specifically an introduction to Elastic Load Balancing, a conceptual overview of Elastic Load Balancing, benefits and use cases of Elastic Load Balancing, cost and price overview, how to create an Elastic Load Balancer, and ELB security, in which we talked about the security groups and having to make sure that proper ports have allow rules. So back to our main diagram, we are now really starting to fill this in, and building on Elastic Load Balancing, we're going to move into auto scaling next. So with that, I will complete this lesson and complete this section. Thank you for watching. You may now move on. Hello and welcome back. In this section, we're going to take a look at auto-scaling and how that adds high availability and fault tolerance to our AWS infrastructure. So let's dive on in and take a look. So this is AWS Essentials Section 10, in which we're focusing on auto-scaling. We're going to include specific topics such as a conceptual overview of auto-scaling components, pricing and cost overview, launch configurations, auto-scaling groups, and how to set up and use auto-scaling. For Lesson 1, we're going to focus on auto-scaling basics, in which we're going to talk about auto-scaling definitions and a conceptual overview. We're then going to have a second basics lesson as part of this same video. So what is autoscaling? For an essentials definition, autoscaling automates the process of adding, scaling up, or removing, scaling down EC2 instances based on traffic demand for your application. For an AWS definition, autoscaling helps to ensure that you have the correct number of Amazon EC2 instances available to handle the load for your application. When you create collections of EC2 instances called autoscaling groups, you can specify the minimum number of instances in each autoscaling group, and autoscaling ensures that your group never goes below this size. You can specify the maximum number of instances in each auto-scaling group, and auto-scaling will ensure that your group will never go above this size. If you specify the desired capacity, either when you create the group or at any time thereafter, auto-scaling ensures that your group has this many instances. If you specify scaling policy, then auto-scaling can launch or terminate instances as demand on your application increases or decreasing. And that's really what we want to focus on, is that autoscaling will automatically increase or decrease, meaning launch or terminate EC2 instances based on the demand, the current users, the current amount of users that are using your web application. And this is one core component of creating high availability and fault tolerance within your AWS architecture. Now, to understand where autoscaling fits in our VPC diagram, autoscaling is a service, not a physical part of the infrastructure. So therefore, autoscaling can span multiple subnets and multiple availability zones, but will always remain within your VPC. Now, for a conceptual review of auto-scaling, let's take a look at a very similar scenario to which we had in the previous section when we talked about elastic load balancing, because elastic load balancing and auto-scaling really go hand in hand. So given this example, let's say that we have two servers set up, each with a max capacity of 3 users. With just elastic load balancing, so no auto-scaling here, what would happen is as those users come in and access your website, they will be evenly distributed between the two servers. And if you have a maximum capacity of 3 users and you have a total of 3 per server, then everything should be working fine. And this prevents, again, elastic load balancing from one server becoming overloading and potentially crashing. But what happens now if your 2 servers with a max capacity of 3 users per server are currently full, but there's more users that all want to access your web application? Well, what might happen in that case is the EC2 instances will become overloaded, possibly crash, or run extremely slow. And this is what we want to avoid. And elastic load balancing, even though it distributes traffic evenly, it can't do anything beyond that. And this is where auto-scaling now comes into play. In this example, we have our elastic load balancer, but now auto-scaling set up for this particular application. So if we have 2 servers with a max capacity of 3 users, and those are both currently full, and 2 more users come along, what auto-scaling can do is add an additional server automatically based on the increased demand for our application. So it will automatically provision and launch a web server for us within one of our subnets, and it will automatically be associated with the elastic load balancer. So now this elastic load balancer will serve traffic between 3 instances. Now, in addition to adding servers based on demand, auto-scaling can also remove servers based on demand. So during periods where traffic is high, it will add servers, but then as traffic decreases, it can remove servers and terminate them, which is very beneficial because then that saves on cost. You don't want to have servers launched in your AWS account that nobody is using. So that is a basic conceptual overview of auto-scaling and why it's used. Moving on to basics part 2, we're going to talk about auto-scaling components and a pricing and cost overview. For auto-scaling components, there are really 2 main parts. First is the launch configuration, and this is the EC2 template used when auto-scaling needs to add an additional server to your auto-scaling group. So in order for auto-scaling to add an EC2 instance, it has to know what instance you want to add. So what is the AMI? What is the instance type? What type of storage? What type of software needs to be installed? It needs all the information so that when it goes to launch an instance for you, it's launching the correct instance for you. Next is the auto-scaling group, and these are all the rules and settings that govern when an EC2 server is automatically added or removed. So this is the type of instance we want to add, and these are the rules that are going to govern when we add it and when we remove it. Next, let's take a quick look at pricing and cost overview. So using auto-scaling is absolutely free. So there's no cost for setting up auto-scaling and having it active in your account. However, you will be charged for the resources that auto-scaling provisions. So if you have auto-scaling set up, that's not going to cost you anything. But if auto-scaling launches 5 servers for you based on demand, then you are going to pay for those 5 servers, assuming that the servers that it launches go above your free tier allotment. So that's a quick overview of auto-scaling, conceptually how to understand auto-scaling, its components, and a cost overview. And with that, I will complete this lesson. Thank you for watching. You may now move on. Hello and welcome back. In this lesson, we are going to dive into setting up auto scaling. Specifically, we're going to touch on launch configurations, auto scaling groups, auto scaling metrics and thresholds, and auto scaling alarms and SNS triggers. So to get started, the first thing we need to do is to create a launch configuration. So to manage auto scaling, once again, we go into EC2. On the left-hand navigation bar, we can scroll down to auto scaling, and there's two options, launch configuration and auto scaling. You have to configure a launch configuration first before you can build an auto scaling group. So we'll start here. So the first thing we need to do when configuring a launch configuration is to select an AMI, and we're going to select the Amazon Linux AMI. Select an instance type. We're going to keep this free tier with T2 Micro. Launch configuration, we're going to give this a name. We'll call it Essentials Launch Configuration, or LC for launch configuration. We'll go down here and click on advanced details because there's a couple things that we want to do here. One, we want to make sure that for IP address type that we are assigning a public IP address. So whether that's assigning a public IP address to every instance and forcing that option, or using the default of only assigning a public IP address to the instance if the default VPC and subnet have that configured by default. And it will, because we're going to choose our public subnet to be a part of this auto scaling configuration and auto scaling group. So it's going to do that for us automatically. But if you're ever not sure, you can always just click on assign a public IP address that it forces that option. Next, I am going to, like I did in the EC2 provisioning lesson, enter in here the bash script that is going to update the Yum installer on our Linux instance, as well as install the Apache web server, so that once everything is launched, we can test out accessing the EC2 instances from an outside computer. Next, I'll click to add storage. I'm just going to leave it as the default root volume. Now for security group, we can have it create a new security group called Auto Scaling Security Group 1. And currently the only allow rule that is here is SSH over port 22, which we will want if we intend to SSH or log into this EC2 instance, which we very well may. But also to serve up web traffic, we are going to have to allow HTTP. Next, we go to review, and then create the launch configuration. Now, with this, since we are automating the process of provisioning EC2 instances, we do have to assign a key pair to the EC2 instances, and I'm going to select the same one that I created and used back in our EC2 section. Next, that rolls right over into creating the auto scaling group. So we'll move over to this section. And the first thing we need to do is give this a group name. So I'll call this Essentials Auto Scaling Group. The group size, this is the amount of instances we want the group to start with. Now, this doesn't necessarily mean it's going to be the minimum or the maximum, but it's going to be the amount we're going to start with. So I'm going to set this to 3 instances to start. Next, select your VPC. We've already selected that. And next, we have to select the subnets. Now, again, these are going to be EC2 instances that we want to serve up web traffic. So they have to be in public subnets. So I'm going to select public subnet 1 and public subnet 2. Then we want to go to advanced details, and this is extremely important because here we have to select to receive traffic from one or more load balancers. So this is where we have to select the load balancer that we created in the previous section so that both our load balancer and auto scaling work together. For health check, we'll switch that to ELB because the Elastic Load Balancer is already doing health checks for us. Next, we can configure scaling policies. And what scaling policies do is this is where we set the thresholds to either increase or decrease based on traffic demand. So first we have to choose what to scale between. Now we're going to start with 3 instances, but let's say that we want to scale, or say that we know for a fact that we're going to require a minimum amount of instances to run our application. Let's say that we want a minimum of 2, meaning we'll never allow for there to be less than 2 instances. But at the same time, we can put a maximum cap, and this is a great way to prevent 10, 15, 20 instances from being provisioned without you knowing. And you can always come back in and readjust these at any time. So let's put a maximum at 5. Next, we have to set the thresholds to increase and decrease based on demand. So first, let's look at increase group size. So for here, what we need to do is add a new alarm. And here is where we can select if we want to send a notification to a specific SNS topic, but we're actually going to do that in the next part. So I'm going to uncheck it, but you can do that here. So what I'm doing here now is that I'm going to say whenever the average CPU utilization of the EC2 instances that are currently live is greater than, let's say, 70%. So that means that there's a good amount of traffic on our EC2 instances and they're not overloaded yet, but they're starting to get to the point where we want to look to add more capacity. So for at least one consecutive period of 5 minutes, and you can change this again to as many periods of minutes or hours that you like. So I will leave it to one consecutive period of 5 minutes. And then this is the name of the alarm. So now what's going to happen is that anytime that there is enough traffic on our application that has driven the CPU utilization average across all the instances above 70%, that is when auto scaling is now going to add an additional EC2 server to our auto scaling group. Now for decreasing, we need to do the exact same thing, just in the opposite direction. So I'm going to uncheck notification here, but we're going to say when average CPU utilization is less than or equal to, let's say, 30%. So that means that if we have 3 or 4 instances currently active and they're all being utilized less than 30%, that means that we can drop one of the EC2 instances and distribute the load between the remaining instances and not have those remaining instances be overloaded. So now that we have our 2 thresholds set up for increasing and decreasing, we can move on to configure notifications. And here we can add a notification and we can have it sent to our auto scaling group alert SNS topic whenever auto scaling launches an instant, terminates an instant, or tries to launch an instant or tries to terminate an instance and fails. So these are great notifications to get because you'll know what auto scaling is doing and when it's adding over moving instances. And these alerts are going to be sent to my auto scaling group SNS topic. Next, you can add tags if you'd like. I'm just going to leave this blank, and then we can review and create the auto scaling group. Now, if we go up to instances, we now see that since we set the start number of instances to 3, autoscaling now is launching and provisioning 3 EC2 instances for us. So I'm going to pause the video for a second and come back once these are done being provisioned. Okay, welcome back. The 3 instances that autoscaling has provisioned for us have finished setting up and being configured. So now let's select one of them. We'll grab the public IP address, and if I go to that in my web browser, we should be able to see the Apache test page. And perfect, we do. So let's try another one. Since they should all be duplicates of each other, I should be able to grab this public IP address here. And perfect. So now one of the great things about elastic load balancing and auto scaling is that it's always going to maintain what our minimum thresholds are. So if I were to go in here and manually terminate two of these instances, we're going to see auto scaling provision an additional instance for us to make sure that we're back to our minimum of 2. So if I go here to instance state, terminate these two, click terminate, these are going to terminate, and once the elastic load balancer and auto scaling do the health checks, it will then re-provision EC2 instances for us. So what I'm doing here is I'm basically mimicking these servers crashing or becoming overloaded. So now this may take a few minutes because it will have to go through the health checks, but I'm going to just pause the video and come back when we start to see the other instances being provisioned. Okay, we're back, and if you see here now, the two instances that I terminated have been terminated, and right here you now see an additional EC2 instance initializing. So this is currently being provisioned for us by auto scaling to meet our minimum threshold of having always 2 EC2 instances running within the auto scaling group. Okay, so lastly, let's take a look at our Project Omega infrastructure requirements for this section. For section 10, we need to automate the process of scaling up or scaling down AWS resources based on traffic demand. Specifically, we have to have a launch configuration and auto scaling group set up to provision EC2 instances based on traffic demand, and have auto scaling group notifications enabled that will trigger an SNS topic when instances are added or terminated from the auto scaling group. We've also done that as well. So great, we have met all the requirements for Project Omega in this section. So to recap, in AWS Essentials Section 10, we focused on auto scaling, in which we went through a conceptual overview of auto scaling components, pricing and cost overview, launch configurations, auto scaling groups, and how to set up and use auto scaling. So now that we have finished with auto scaling, we are getting very close to being done with Project Omega's configuration and understanding all of these various components. Next, we're going to move into Route 53 and touch on how Amazon Web Services handles domain names and DNS. But for now, we will conclude this lesson and conclude this section. Thank you for watching. You may now move on. Hello and welcome back. We are getting close to the end here. We are now into our second to last section, in which we're going to talk about Route 53. So let's go ahead and turn this section on and dive on in. So for AWS Essentials Section 11, we're going to talk about Route 53. Specifically, we're going to touch on an overview of Route 53, DNS servers, how your computer locates a web server across the internet, registering a web domain, and also configuring Route 53 to use that domain. Route 53 Lesson 1, focusing on Route 53 basics, will touch specifically on Route 53 definitions, DNS servers, understanding how web servers are located across the internet, and Route 53 pricing overview. So jumping in, let's talk specifically about what is Route 53. For an essentials or easy definition, Route 53 is where you configure and manage web domains for websites or applications you host on AWS. So broadly, whenever you think of Route 53, just think of Route 53 as where you go to manage web domains in AWS. Now, expanding on that, we can take a look at the AWS definition, and AWS defines it as Route 53 performs 3 main functions. One, which we've already touched on, is domain registration. Amazon Route 53 lets you register domain names such as example.com or linuxacademy.com or projectomega.com. Next, it allows you to manage domain name system DNS service. So Amazon Route 53 translates friendly domain names like example.com into IP addresses like 192.0.2.1. Amazon Route 53 responds to DNS queries using a global network of authoritative DNS servers, which reduces latency. And we're going to dive a little bit more into an explanation of DNS coming up. Next is health checking. Amazon Route 53 sends automated requests over the internet to your application to verify that it is reachable, available, and functional. You can use any combination of these functions. For example, you can use Amazon Route 53 as both your registrar for your web domain and your DNS service. Or you can use Amazon Route 53 as the DNS service for a domain that you register with another domain registrar. Okay, so now building on what we have here for Route 53, let's take a look at a general example to understand how domains and DNS fit together to make websites accessible to visitors. So this is going to be an explanation of why a service like Route 53 exists and why it's needed. So let's say that we have a general visitor to a website. This is you sitting at your computer and you want to go to linuxacademy.com. What happens internally when a user enters www.linuxacademy.com into a web browser? So if I were just to put linuxacademy.com here or linuxacademy.com here, what happens under the hood to then deliver that web content back to me? So now let's actually take the role of the computer. And the computer, when I type in linuxacademy.com, thinks to itself, I know the user wants me to get the website linuxacademy.com, but I have no idea where its host server is located on the internet. I need the address. That's what the computer says to itself. So what happens then? So here we now have the Linux Academy server, which has an IP address, a public IP address, and we have the computer, which we've input www.linuxacademy.com. Now, the connection between the two cannot be established because the computer does not know the IP address of the Linux Academy server. And the computer needs the IP address in order to route across the internet to that server, grab the information for the website, and then send it back to the computer to have it be displayed to the user. So there has to be a third party here. There has to be something, some way for the computer to get the IP address of the Linux Academy server. And this is where DNS servers come into play. So a DNS server is a database of website domains and their corresponding IP addresses. Web browsers send me, being the DNS server, domain names, and I return the correct IP address so they, meaning the user of the computer, can find the server on the internet. So when I type in, or if you type in linuxacademy.com into your computer, if your computer does not know the IP address for the Linux Academy server, it will send a request to one of many DNS servers that are available on the internet. So I want you to think about a DNS server like this. Think about the cell phone that you may have, and think about the contacts that you have programmed into your cell phone. When you decide that you want to call or text somebody, you don't sort or find them by their phone number. You, using common language, just use their name. However, in order for your phone to connect to the cellular network and find the correct place to send that phone call or that text message, they need to use the phone number, not the person's name that you've used to store the information under. So the same thing is happening here. linuxacademy.com is the person's name in your contact, and the IP address is their phone number in your contacts. But we are only telling the computer to, hey, get me linuxacademy.com, but on our computer, we don't have the corresponding phone number or the corresponding IP address in this instance. So it has to go to The contact list, in this case, that is a DNS server run by a third party, which has a database of both the common language URL or domain names, linuxacademy.com, and its matching IP address. So we ask the DNS server, hey, here's linuxacademy.com. I need to know the IP address. It says, okay, great. I have that information for you. Here's the IP address. It sends that IP address back. And then what happens is we should be able to access the Linux Academy server. Now, we should note that web admins must register their web domain and IP address with DNS providers if they want users to find their website without knowing the IP address. So if you set up a domain and a web server, you have to register your domain name and the corresponding IP address with a particular or many DNS server providers. So once that whole transaction takes place and we get the IP address from the DNS servers, then the connection can be made and information can be sent back and forth, because having the IP address, the computer now knows how to route correctly to the server and back. So with that example now explained, let's take a look at our VPC diagram and understand exactly what's happening when customers may come and want to access Project Omega. So first, we now see that we have Route 53 in the diagram. So when we use Route 53, the first thing we're going to do is register a domain name. So say we want to register projectomega.com, or if that's not available, some other variant of projectomega.com. When we register that using Route 53, we then need to send information to DNS servers so that DNS servers have the web domain name as well as the corresponding IP address. So now when a customer types in www.projectomega.com or whatever variant we're going to register in the next video, which is what we're going to do, what's going to happen is across the internet, that request is going to go to the DNS server. The DNS server is going to send back the IP address. The customer will then go through the internet, down through Route 53, in through the internet gateway. And ultimately, what's going to happen is the IP address that is given to the DNS server is going to be the IP address of our Elastic Load Balancer, because then the Elastic Load Balancer will distribute incoming traffic down to the various web servers that we have hosted using the Elastic Load Balancer and our auto-scaling group. So that's how this fits into the overall picture of AWS architecture. So quickly, we'll recap. For Route 53, just remember that it is for managing domain names and DNS records. And when you think of DNS records, just think of like a phone book or contact list, where you have one piece of information, but you need a corresponding piece of information, meaning an IP address, to be able to properly route across the internet to find the server that you're looking for. Lastly, let's just touch quickly on Route 53 price and cost overview. Now, some of these are going to be more advanced features, things that you're not going to use right away, but I just want you to be aware of what these things are, and you can always go to the link down here to see these things laid out in greater detail. But please note that free tier use is not available for Route 53. Anything you do with Route 53 is going to cost money, and you are charged based on the number of hosted zones, and we're going to touch on that in the next lesson, traffic flow per policy, standard queries, latency-based routing, GeoDNS queries, health checks, and then lastly, to register or transfer a domain into Route 53. So that, in summary, is a quick explanation of the Route 53 basics, including an overview of DNS and how web browsers find the correct information or the IP address needed to access web servers across the internet. And with that, we will conclude this video. Thank you for watching. You may now move on. Hello and welcome back. All right, in this lesson, we are going to get our hands dirty with Route 53, in which we are going to specifically go about registering a domain, setting up a hosted zone, configuring record sets, and routing traffic to the Elastic Load Balancer. So, however, before we move on to that, let's just recap what we finished off with last lesson in discussing how we're going to use Route 53 and what we're going to set up. So in Route 53, we're going to register a domain. We were then going to create a hosted zone, which is going to include our DNS record set that are going to be sent to the DNS server. This will allow customers, when they type in the URL that we're going to register, will be able to get the IP address associated with that domain. Now, that IP address will be the IP address of our Elastic Load Balancer. So when a customer types in the URL, they will go to the DNS server, they will get the IP address will be sent back. The web browser will then use that IP address, go through the internet through Route 53, and Route 53 is going to see that traffic and it's going to point it directly to the Elastic Load Balancer. Then the Elastic Load Balancer, being associated with currently 2 web servers, is going to distribute that traffic to one of the 2 web servers. So at the very end, if everything is working properly, we should get the Apache test page displayed to us when we type in the URL, and that's the same test page that we set up and configured back in the EC2 section of this course. So now let's get into the actual processes. To find Route 53, it's going to be under networking and content delivery right under VPC. So immediately we're dealing with an empty Route 53. We don't have anything configured, but the first thing we want to do is actually register a domain. So I'm going to click on that and then click on register domain. Now, this is going to cost money. It costs $12 currently, as of the time of this recording, to either register a new domain or transfer a domain into Route 53. So now you do not have to follow along with this if you do not want to spend the money, and that's perfectly fine. But I'm going to go through the process here and spend the money so that you can all see exactly how this works. Now, I've already found a web domain that we can use called Project Omega 1. That should be available. Project Omega, unfortunately, was already taken, but projectomega1.com is available, so I'm going to add that to my cart, and I'm going to click continue. I'm now going to fill in all of my contact information. So I'm actually going to cut the video here, just because this is my personal private information, but just go about filling out this form. And one thing that I do want you to note is that at the bottom here, there is this privacy protection option. And this is where if anybody wants to look up the owner of this URL, then I can either choose to have that information available or have it hidden. So that all depends on your own personal preference, but for the purposes of this video, I will choose to don't hide contact information. So if somebody went to a domain name lookup and typed in projectomega1.com, they would come up and they would be able to see and view my information. And then once I'm done filling out the information, I will click continue here. So I'm going to pause the video now and I'll be right back. Okay, I've gone through, I completed the rest of the form, and now it's just taking me to a confirmation screen saying thank you for registering your domain on Route 53. Now, a couple of things are going to happen. And first, I want to note that I didn't have to put in a credit card number or anything else in terms of payment. It's going to just charge my AWS account directly for the $12 for registering the domain. So if you already have an AWS account set up and your credit card is input there and you decide to take this step for yourself, just know it'll directly charge your account and you'll be billed at the end of the month. So now I'll click on go to domains, and you're going to see here that it says domain registration in process. Now this may take a little bit of time. It could take anywhere from 5 to 15 minutes to 20 minutes. So I'm going to pause the video again and I'll come back once this process is done. And what's actually happening a little bit under the hood here is it's actually creating and setting up the hosted zone and initial record sets for us, which is great, which means that we don't have to go in and do that manually, but there will be some manual configuration we're going to have to do in the next steps, but I will return once the domain is done registering. Be right back. Okay, I'm back, and what I've done is I've clicked on dashboard here, and it's brought up this new interface for us, and we see here that for projectomega1.com, the domain registration has been successful, which is great, meaning that we can move on. Also, you will see that hosted zones now has a value of 1, and that is going to be the area that we move into next in terms of setting up the hosted zone and record set. So let's jump into our hosted zones. And under your hosted zones, if you have multiple domain names, you will see those listed here, but we're going to click on Project Omega. So this is the hosted zone for Project Omega. And we're already going to see that there are already 2 record sets in here. And this is what AWS did for us when they set up our hosted zone. And these are 2 different types of DNS records. Now, I'm going to show you a few things here, but I'm not going to get into the details and explanations of all these different types of DNS records. It's really outside the scope of this course. For this course, what I want you to know about Route 53 is just how it's used for domain registration and DNS management without going into the nitty-gritty details. You just need to be aware of what Route 53 does and what its purpose is. Everything else I'm showing you here is just kind of a little bit of a bonus to give you a little more insight of what goes on under the hood when you type a web address or URL into your browser and what happens and how it actually accesses web servers. So now that we actually have our domain registered, we now need to create 2 DNS records for the URL, make sure those are sent to DNS servers, and then also point that web domain to our Elastic Load Balancer. So we do that all in the same process of creating record sets. So what I'm going to do is click right up here, create record set, and I'm going to create 2 record sets, one just for projectomega1.com, and I'll do this one first, one for www.projectomega.com. So you need to have both of those covered. For type, these are the different types of record sets. We're going to leave this as A for IPv4 addresses, which is just a standard IP address format. This is going to be an alias, and the alias target is going to be, and it's pre-populated for us, our Elastic Load Balancer. So all I need to do is click on that there. Routing policy will be left as simple, but there are different types of routing policies that you can implement. And for evaluate target health, generally you would probably want this to be yes, but that will have to do with DNS failover, which is far outside the scope of this course. For now, I'm just going to leave it as no. So as simple as that, I'm going to hit create. And then it'll go back in. I'm going to do it again, but leaving this blank and clicking on alias yes. We're going to enter the Elastic Load Balancer, simple, and click create. So perfect. We now have created 2 type A DNS record sets. And what AWS and Route 53 is doing for us right now automatically is they are sending this information out to DNS servers for us. So we don't have to do that manually. We create the record sets, and a great thing about Route 53 is it handles all of that back-end stuff for us. So now all I need to do is wait, I don't know, maybe around 60 seconds to a few minutes for these DNS records to propagate out to the DNS servers, and then I should be able to open up my own web browser, type in projectomega1.com, and we should see the Apache test page. So I'm going to pause the video, and I'll be right back. Okay, I've given it a little bit of time for the DNS records to propagate out to various DNS servers, so let's give this a try. So paste in projectomega1.com. Let's hit enter and see what happens. Perfect. This is exactly what we wanted to happen. The web domain that I registered with Route 53, projectomega1.com, I put that into the web browser and it brought up our Amazon Linux AMI Apache test page. This is perfect. This is exactly what we wanted to happen. So just to reiterate, this is what is now occurring. If you remember our 2 EC2 web servers, so I can bring those up here. The various web servers that we set up with the Apache test page, which are associated with our Elastic Load Balancer. So if I click on the Elastic Load Balancer, and we can see the instances that are associated with it, which are actually these three. So we can look at an instance ID 108A. So 108A. So if we look at this instance right here, this is a public IP address. So what's happening is, let's say that this instance right here is this instance here. So what's happening is that the customer, in this case, this was me right here when I typed in www.projectomega1.com, it went to the DNS server. It asked the DNS server, it said, hey, here's projectomega1.com. I need the IP address. It sent back the IP address, and the DNS server knew the IP address because Route 53 gave the DNS server the IP address of the Elastic Load Balancer. So once the IP address goes back to the customer's web browser then goes through the internet, and it knows exactly where it needs to go. So the data gets transmitted down through Route 53 through the internet gateway to the Elastic Load Balancer. The Elastic Load Balancer takes that, and it is going to then send the traffic to one of the available web servers. In this case, let's say it's this web server right here, sends the information down through our network access control list, then into the subnet, through the security group, and then to our web server. It retrieves the information, which in this case is the Apache test page, and the Apache test page information goes back out through the internet, back to the customer, and right here back to my web browser. So I hope this is becoming clear in more of a totality now, or an entirety of how fault-tolerant, highly available architecture works within Amazon Web Services, and what one of the primary uses of AWS is. And this is one of the primary uses of AWS, is hosting websites that are highly available, fault-tolerant, using EC2 instances, security groups, subnets, network access control lists, Elastic Load Balancers, internet gateways, VPCs, Route 53, propagating information to DNS servers, and ultimately allowing the customer to access your website. Okay, so now that we're finishing up this lesson in this section, let's take a quick look at our requirements for Project Omega. So for section 11, we needed to set up and configure a web domain that points to Project Omega's infrastructure. So we had to register a domain name in Route 53. We did that. We needed to create a hosted zone. Now, one of the great things is when you register a domain with Route 53, it creates a hosted zone for you. But we then needed to create record sets for both www and non-www domain name variants, which we did. We created those 2A records. Then route the records to the Elastic Load Balancer, which we did, and then test the domain is accessible from the web, which we did right here. So to recap, this was AWS Essentials Section 11, in which we talked about Route 53. We touched on topics that include an overview of Route 53. We talked about DNS servers and their purpose, how your computer locates a web server across the internet, registering a web domain with Route 53, and finally, configuring Route 53 to use that domain by both populating DNS servers with the proper information and routing incoming traffic to an Elastic Load Balancer. So now that we are finished with this section, we can take a look. As we almost have our entire diagram built in, we're going to move into the last section next, which is Lambda, which is some really interesting new technology. But for now, we will complete this lesson and this section. Thank you for watching. You may now move on. Hello and welcome back. Well, we've made it to the final section of AWS Essentials, in which we're going to talk about Lambda. So let's go ahead and turn this section on and dive on in. So for AWS Essentials Section 12, we're going to focus on Lambda, and we're going to touch on an introduction to AWS Lambda, an overview of serverless computing, a pricing and cost overview, and lastly, using Lambda to execute code. For this lesson, lesson 1, we're going to focus on Lambda basics, in which we'll cover Lambda definitions and a general overview of serverless computing. So what is Lambda? Well, an essentials definition sounds something like this. Lambda is serverless computing. It is the next generation of cloud computing that will replace EC2 instances for the most part. So I qualify that a bit in that there are some differences and there still may be uses for things like EC2 instances in the future. For AWS's definition, we get much more involved and it touches on some key factors here. And this states that AWS Lambda is a compute service that lets you run code without provisioning or managing servers. So that part of the sentence right there, run code without provisioning or managing servers, is what is referred to as serverless computing. AWS Lambda executes your code only when needed and scales automatically from a few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application or backend service, all with zero administration. AWS Lambda runs your code on highly available compute infrastructure and performs all of the administration of the compute resources, including server and operation system maintenance, capacity provisioning, and automatic scaling, code monitoring, and logging. All you need to do is supply your code in one of the languages that AWS Lambda supports, which currently include Node.js, Java, C#, and Python. So that's a lot. What does this all mean? Well, let's break it down into a very oversimplified example. And for that, let's take a look at what we've been working on for the last few lessons. So currently for Project Omega, we have a few web servers set up that are running, we'll call for now, the Project Omega code, which is just the Apache test page, but we have those in subnets, which are then in availability zones, running on an auto-scaling group, using an elastic load balancer to route traffic with an internet gateway inside of VPC, and then using Route 53 and DNS servers to make sure that customers from the internet can properly find and route traffic into our Project Omega infrastructure. So what does Lambda do to all of this? Well, Lambda basically does this. It replaces all of that. This is, again, a bit of an over-exaggeration because there's still going to be things like Route 53, DNS servers, and obviously some routing you'll have to do to bring traffic in. But when you talk about specific web servers, availability zones, subnets, auto-scaling groups, elastic load balancers, and pretty much the VPC as a whole, Lambda is going to be a service that just takes care of all of that for you. You're not going to have to make decisions about how many EC2 instances to provision, buying a spot or a reserved instance, or auto-scaling groups, or trying to figure out how much capacity you're going to need, because Lambda is going to do that all for you. And I'm going to give you this example. Picture the computer that is currently in front of you that you're watching this lesson on. It can be a desktop, a laptop, a cell phone, or a tablet, but that computer that you're using has a specific capacity of compute power and storage. So if you're using only, say, one application currently, then you're probably underutilizing what your computer capacity is. But let's say you wanted to run 30 applications, well, that may be greater than your current compute capacity, and therefore you can't do that, and you would have to go buy a new computer, or in AWS's case, you would have to provision another EC2 instance. But what if you didn't have to do that anymore? What if the computer in front of you, your laptop, your cell phone, or whatever, always just had the exact amount of compute power that you needed at any given time? So let's say you were just running one application on your laptop. What if your computer at that moment only had that amount of capacity and that's all you were paying for? But then, let's say you suddenly wanted to run 30 applications, instantly your computer compute power would scale up to be able to handle those 30 applications. And you didn't have to do anything to achieve that increase in capacity. It was all handled for you. And you never have to update your operating system. You would never have to add more RAM or increase the size of your hard drive. Just imagine if that was all done for you. That's what serverless computing is, and that's what Lambda is. And what you end up doing is only paying for exactly the amount of compute power that you're using at any given time. So that will roll us over into the pricing and cost overview. So first, let's note that free tier use is available for Lambda in a limited fashion. So obviously always go to this link down here to view current pricing and current free tier limits that you have for Lambda. There are two main ways that Lambda will charge you for using its service. The first is request to execute code. So anytime that you want to execute the code that you put into Lambda that would otherwise be running on your EC2 instance, it will charge you for each time that you want to run the code. Then there's the duration that it takes to execute the code. Let's say that takes only 3 seconds. Well, you'll pay for the one request to run the code, and then you're only going to pay for the compute power that you use for the 3 seconds that it takes to run the code. And that actually breaks down to the point where you're only being charged to the millisecond for the duration that it takes to execute the code. So instead of provisioning an EC2 instance and having that EC2 instance run for hours, days, or months, you can have code just sitting in Lambda, and if that code only takes 3 seconds to execute, you're only paying for 3 seconds of compute time as opposed to paying for an EC2 instance for a day, a week, a month, or a year. Lastly, you can also be charged for accessing data from other AWS services or resources, like if you have a Lambda function that needs to access content or code that needs to access data that may be in S3, there can be a charge for that as well. But these are the two ways that I want you to remember as the primary ways that you'll be charged for using AWS Lambda. And I focus more on the cost structure for Lambda than I did for other AWS services, because this is one of the major features of Lambda is this new cost paradigm or this new cost structure that's very different from traditional server type networking. Okay, so again, to sum everything up, if you walk away from this course, just remember one thing, that Lambda is AWS's serverless platform. And serverless means that you can run code without provisioning or managing servers. So if you just remember that piece of information from this, then that will be good enough for you moving forward. And with that, we will conclude this lesson. Thank you for watching. You may now move on. Hello and welcome back. Well, we've made it to the final section of AWS Essentials in which we're going to talk about Lambda. So let's go ahead and turn this section on and dive on in. So for AWS Essentials Section 12, we're going to focus on Lambda, and we're going to touch on an introduction to AWS Lambda, an overview of serverless computing, a pricing and cost overview, and lastly, using Lambda to execute code. For this lesson, Lesson 1, we're going to focus on Lambda basics, in which we will cover Lambda definitions and a general overview of serverless computing. So what is Lambda? Well, an essentials definition sounds something like this. Lambda is serverless computing. It is the next generation of cloud computing that will replace EC2 instances for the most part. So I qualify that a bit in that there are some differences and there still may be uses for things like EC2 instances in the future. For AWS's definition, we get much more involved and it touches on some key factors here. And this states that AWS Lambda is a compute service that lets you run code without provisioning or managing servers. So that part of the sentence right there, run code without provisioning or managing servers, is what is referred to as serverless computing. AWS Lambda executes your code only when needed and scales automatically from a few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application or backend service, all with zero administration. AWS Lambda runs your code on highly available compute infrastructure and performs all of the administration of the compute resources, including server and operation system maintenance, capacity provisioning and automatic scaling, code monitoring, and logging. All you need to do is supply your code in one of the languages that AWS Lambda supports, which currently include Node.js, Java, C#, and Python. So that's a lot. What does this all mean? Well, let's break it down into a very oversimplified example. And for that, let's take a look at what we've been working on for the last few lessons. So currently for Project Omega, we have a few web servers set up that are running, we'll call for now, the Project Omega code, which is just the Apache test page, but we have those in subnets, which are then in availability zones, running on an auto-scaling group, using an elastic load balancer to route traffic with an internet gateway inside of VPC, and then using Route 53 and DNS servers to make sure that customers from the internet can properly find and route traffic into our Project Omega infrastructure. So what does Lambda do to all of this? Well, Lambda basically does this. It replaces all of that. And this is, again, a bit of an over-exaggeration because there's still going to be things like Route 53, DNS servers, and obviously some routing you'll have to do to bring traffic in. But when you talk about specific web servers, availability zones, subnets, auto-scaling groups, elastic load balancers, and pretty much the VPC as a whole, Lambda is going to be a service that just takes care of all of that for you. You're not going to have to make decisions about how many EC2 instances to provision, buying a spot or a reserved instance, or auto-scaling groups, or trying to figure out how much capacity you're going to need, because Lambda is going to do that all for you. And I'm going to give you this example. Picture the computer that is currently in front of you that you're watching this lesson on. It can be a desktop, a laptop, a cell phone, or a tablet, but that computer that you're using has a specific capacity of compute power and storage. So if you're using only, say, one application currently, then you're probably underutilizing what your computer capacity is. But let's say you wanted to run 30 applications. Well, that may be greater than your current compute capacity, and therefore you can't do that, and you would have to go buy a new computer, or in AWS's case, you would have to provision another EC2 instance. But what if you didn't have to do that anymore? What if the computer in front of you, your laptop, your cell phone, or whatever, always just had the exact amount of compute power that you needed at any given time? So let's say you were just running one application on your laptop. What if your computer at that moment only had that amount of capacity, and that's all you were paying for? But then, let's say you suddenly wanted to run 30 applications. Instantly, your computer compute power would scale up to be able to handle those 30 applications. And you didn't have to do anything to achieve that increase in capacity. It was all handled for you. And you never have to update your operating system. You would never have to add more RAM or increase the size of your hard drive. Just imagine if that was all done for you. That's what serverless computing is, and that's what Lambda is. And what you end up doing is only paying for exactly the amount of compute power that you are using at any given time. So that will roll us over into the pricing and cost overview. So first, let's note that free tier use is available for Lambda in a limited fashion. So obviously always go to this link down here to view current pricing and current free tier limits that you have for Lambda. There are two main ways that Lambda will charge you for using its service. The first is request to execute code. So anytime that you want to execute the code that you put into Lambda that would otherwise be running on your EC2 instance, it will charge you for each time that you want to run the code. Then there's the duration that it takes to execute the code. Let's say that takes only 3 seconds. Well, you'll pay for the one request to run the code, and then you're only going to pay for the compute power that you use for the 3 seconds that it takes to run the code. And that actually breaks down to the point where you're only being charged to the millisecond for the duration that it takes to execute the code. So instead of provisioning an EC2 instance and having that EC2 instance run for hours, days, or months, you can have code just sitting in Lambda, and if that code only takes 3 seconds to execute, you're only paying for 3 seconds of compute time as opposed to paying for an EC2 instance for a day, a week, a month, or a year. Lastly, you can also be charged for accessing data from other AWS services or resources, like if you have a Lambda function that needs to access content or code that needs to access data that may be in S3, there can be a charge for that as well. But these are the two ways that I want you to remember as the primary ways that you'll be charged for using AWS Lambda. And I focus more on the cost structure for Lambda than I did for other AWS services, because this is one of the major features of Lambda is this new cost paradigm or this new cost structure that's very different from traditional server type networking. Okay, so again, to sum everything up, if you walk away from this course, just remember one thing, that Lambda is AWS's serverless platform. And serverless means that you can run code without provisioning or managing servers. So if you just remember that piece of information from this, then that